Doctor, please allow me to share the screen. It says the host only can do it.
Yeah, get it. Got it. 1 second.
Yeah.
Sorry.
Yeah.
Now you can proceed, ma'am, please.
Yeah, okay.
Thank you.
Are you able to see the screen?
Yes, ma'am, it is visible, clear, ma'am.
Yeah, okay.
Ma'am, can you proceed with full screen, ma'am, that the slideshow?
Yeah. I will adjust everything and then I will make it full screen. Yeah.
Fine, ma'am, fine.
Yeah.
Clear, ma'am. Sir, clear. Your voice also very clear.
Yeah, is it okay now? Can I start?
Yeah, exactly, ma'am.
But
One
number of
second.
participants, are you waiting for some
Yeah.
others?
No need to wait because we have some short of time also. You have class also. Just to go with the formal info, then we can proceed with the lecture, ma'am.
Okay, then you can record the session, sir.
Yeah. That I already put my YouTube live stream. I will share to you for the betterment of other participants also.
The YouTube is not shared with me. Can you share that with me?
Sure, ma'am. But now only it is started streaming. I will share you after. Okay, ma'am.
Okay, fine. Yeah.
Thanks. Dear participant, welcome you all. On behalf of the Institutional Innovation Council, on my own behalf, I wholeheartedly welcome you for this virtual international conference. First, we have the chief guest address by Dr. Nalini R. Uttaman, is currently Assistant Professor, Department of Applied Science and Pharmacy, University of Technology and Applied Science, Muscat, Oman. Her formal training includes a PhD in Polymer Technology from Anna University, Chennai, MSc MPhil in Polymer Chemistry from the University of Madras, MTech and Polymer Science and Engineering from Anna University, Chennai, India. With expertise in polymer technology, her research interests include development and characterization of polymer blends, polymer concrete, and plastics recycling. She was actively engaged in funded projects in the areas of the flame retardant, fiber reinforced polyester formulation for roofing applications, and the development of polyaniline based conducting nanocomposites. She has published papers in international journals of review. With vast experience of 28 years, she is specialized in teaching polymer waste management, composite technology, organic chemistry, polymer science, and nanotechnology. With this short bio, I would like to welcome Dr. Nalini ma'am to enlighten us. I wholeheartedly thank on behalf of Sacred Heart College, ma'am accepted our invitation in short span of time. Even though ma'am has working day today, she has class in Muscat. From morning onwards, I feel very happy to be associated with Dr. Nalini for her lecture. Thank you, ma'am. Now the dais is yours. Kindly proceed, ma'am.
Yeah, thank you, Dr. Nias, for welcoming me and giving me this good introduction. I would like to thank Dr. Nias and the Innovation Cell of your college for conducting this virtual international conference on innovation in life sciences. So I would like to focus my topic for the students for the emphasis of nanofibers on life sciences. Life sciences, basically medical, biomedical applications. So the content of my presentation, Doctor, it's not, I'm not able to, the contents of the presentation are: what are nanofibers? How are nanofibers formed? Properties of nanofibers and applications. I'm focusing on drug delivery, filtration and separation, and a little bit of electronics and biomedical applications. So basically, what is the meaning of, now everywhere you see people are talking about nano. Nano means something that is miniature. Miniature to what extent? Miniature, like olden days when we have seen the computers, how huge it was. Then basically now if you see, you have even a very, very small device, and the technology is growing so much that even miniature or micro miniature devices are going to, we have seen so many like applications of your cell phones. Look at the kind of batteries which were there earlier and now how it is. If you've seen ACs at home, it will say silver nanoparticles. The filter is made of much better materials than what it was a few years back. And the growth of technology from the last 5-6 years has been extremely huge. And about actually, the statistics shows in the last 5 to 7 years, there are 20 million jobs which are offered in the field of nanotechnology or nanomaterials. What is so great about it? The miniature size. You have 0 dimension, 1 dimension, 2 dimension nanoparticles. And the nanoparticles, nano means very small. So you have approximately dimensions which are far less than 100 nanometers, or even you have 2-3 nanometers. And what happens when you compare a bulk material with the nanomaterial? The bulk material have properties which are different from the normal. Like suppose you take a bulk of calcium carbonate. Okay, I think all of you are science background, so calcium carbonate. Calcium carbonate in your chemistry lab, if you have seen, you can have in the powder form as well as like small stones like agglomerates. So if you see, the bulk particle will have a very much different property compared to the nanomaterial. The nano size, the size of the particle is giving you that particular property. And what are the unique properties? Unique properties can be optical properties, your reflection, your transmission, any property where light is involved, okay? Magnetic properties, electrical properties, all these properties will have a large effect when the size is becoming smaller. With respect to, I'm not very good at biology, but with respect to your area, see if you can see on the left of the screen, you have all these bacteria, red blood cells, your hair is all these are the very, very nano-sized materials. Like, for example, the hair of the insect, the hair of the lizard, your DNA, the RNA, all this in the same. Look at all these are, see the diameter of this nanoparticle this is the hexagonal particle. Look at this. You have, these are all examples of nanoparticles. And these nanoparticles, basically where they are used within the system, within the body, is for medical applications, for filtration. Then you can have drug delivery systems. I'm focusing on this because it's based on your request of life sciences. Okay, then you can have in the defense industry, energy storage, electronics industry. Okay, so the nanomaterial and nanofiber. Fiber is what? Fiber is where the length, fiber is also a polymer, where the length to diameter ratio is greater than 100. That's the difference between polyethylene terephthalate being used as a fiber and polyethylene terephthalate used in the normal application, like for example, the water bottle application. All right. So the difference is the woven fibers can be used in as a nanofiber. Okay, so nanofiber has specific properties. And what are the properties? You have a large surface area covered. You have surface functionalization possible. What is the meaning of surface functionalization? If you see functionalization, functionalization is a chemistry aspect where you have reactive groups. Okay, so this term of functionalization will be where you have reactive end groups, and those reactive end groups, you can change or you can tailor make your properties such that you can get useful applications. Like for example, you can have your medical application, you can tailor make the property for that. So next is, what is this tunnelable porosity? This is also the ability to design and adjust the size, the distribution, and connectivity of the pores. Pores means like holes, small holes. Okay. And this is also for a specific requirement. Then, if a nanofibers example, you can have a wide range of material selection depending upon what kind of application you want, and you can have good mechanical performance. Okay, the next slide, I'm just giving you a video for that you understand what is really the concept of nanofibers.
Welcome to the world of nanofibers. Nanofibers are so tiny that you never see one with the naked eye. What you see is only a reflection of light. Their true image can only be seen using an electron microscope. Nanofibers are part of the nano world, where sizes measure around 1/1,000,000th of a meter. Nanofibers are already changing our lives, giving new properties in things around us. A small drop of polymer solution is the starting point in making nanofiber. The drop is electrically charged in a high voltage electric field to give birth to nanofiber. The fibers are laid over each other, resulting in a nanofiber mat. You can get an idea of the small size of nanofiber by comparison with bacteria, which are unable to penetrate through a nanofiber mat, as the pore size of the mat is much smaller than the size of the bacteria. Nanofibers are thus capable of protecting against bacteria and viruses. A nanofiber membrane can stop water from passing through, such as through clothes. Drops of water slip away on the mat's surface. However, textile materials of nanofibers are very breathable because air molecules can get through the same membrane easily. For example, a nanofiber breathing mask prevents bacteria from being inhaled, yet at the same time allows comfortable breathing. There are hundreds of nanofiber applications. Owing to their specific characteristics, nanofibers are a revolutionary material for the third millennium.
Yeah, I think you got an idea about what the fiber is and specifically to the kind of life sciences application and what's been threatened with all of us, right? The bacteria, the viruses now, so many issues with the, like even you get normal cold, people are so worried, and whether it is COVID, whether the kind of, you people know better than me in the biology aspect. Yeah. So with this is the nanofiber application, and more specifically with the mask application. So what happens or what are the properties which make nanomaterials or nanofibers suitable for the kind of applications which we can tailor make. The first one is the tensile strength. So tensile strength will be very high, and depending upon, like for example, your carbon fiber. Aramid fibers are specifically used for aeronautical applications. That is also a fiber which can be made as a nanofiber. Next, as I told you in my previous slide, you have the high surface area. Surface area, again, is very, very important when you are going to use materials or properties where the surface properties are very critical. Next, you have electrical conductivity. This is especially in electronics applications, in sensors. Then you need porosity. Porosity is the filtration application, drug delivery application, desalination application. All these are the 4 main properties of your nanomaterials: tensile strength, high surface area, electrical conductivity, and porosity. Now, how are these nanomaterials made? The nanomaterials are made, or the nanofibers are made by either the olden methods or by the modern methods. The olden methods, you have electrospinning, you have template-based synthesis, and then you have sonochemical synthesis. You can have polymerization and you can have self-assembly. But this electrospinning technology is the one, though it is, they say it's conventional, this is being used widely even now. So then the modern methods are electro-hydrodynamic wiring, solution blow spinning, carbon dioxide laser supersonic spinning, centrifugal jet spinning, and plasma-induced synthesis. This is just to give you an overview of the various synthesis methods. So basically, what are the materials that can be used? The nanomaterials, if you think about a nanofiber itself, the first thing is priority will be the polymer. You can have natural polymers. Natural polymers, example, polylactic acid or caprolactones. Caprolactones also will come under this category. So both, I think you know what is a natural one. Natural one is available in nature or what you get from nature straight away. The synthetic ones are ones we prepare in the labs. Okay. So these are the priority materials for your fiber application. Then you can have semiconducting materials. You can have carbon-based materials. Metals also can be used, and composite materials. Composite materials meaning you have a reinforcement. Okay, this is more for the automobile applications or other applications where the impact is very important. Okay, so here in the, though it is traditional, you have different types. You can have blend electrospinning. You can have coaxial electrospinning. You can have emulsion electrospinning, and you can have side-by-side electrospinning. See, for example, these diagrams itself will give you an idea of how the fibers are made. See, here you have 2 polymer solutions, polymer A and polymer B. They are blended together. Blending is nothing, just mixing together. And then they are passed through a spinneret or through a small hole, or you have this injection pump, and then you pass current through that, and then you get the fibers. So what happens here, when you blend electrospin, you can have your properties. See, whatever kind of properties you want in your nanomaterial, you can introduce based on the 2 polymers that you're choosing. Is it clear to all of you? Now, look at the next one, the coaxial electrospinning. In the coaxial electrospinning, again, the procedure is the same. The only thing is you have one core solution and you have another solution here. Solution, basically your polymers. So depending upon the various ratios, you can have this kind of impregnation of one into the other. Okay, so this is the second method. In emulsion polymerization, some of you would have heard if you're a chemistry background. In emulsion polymerization, you have an emulsifying agent which is also added along with your polymer solution. So for example, your polymer need not be like, you can add nanoparticles here along with the polymer, and in the presence of this emulsifying agent, like you tailor make the properties, and then you can make your fiber. You can spin your fiber. Now, this is like here again, look at the structure. You have two different colors here. So in this case also you have polymer A, polymer. The only difference these two are, here the blending is prior to your spinning. Here the two solutions are kept separately and then you can spin your fiber. So this is a basic understanding of how electro spinning is used for the preparation of a nanofiber. Now, in this nanofiber morphology means how your surface structure of your nanofiber is going to be. So, if depending upon the concentration of the polymer, okay, you can increase your fiber diameter. Depending upon the viscosity of the solution, if the viscosity is too high, the fiber cannot come out, right? So these properties, your surface tension, the conductivity, the molecular weight of the polymer, the volatility of the solvent which you're choosing, the dielectric constant, all these parameters can be varied in order to have an effect on the way or the surface structure. That is what is called morphology. Okay. Next is, you can have the flow rate. What voltage of current are you passing? Then you can have the geometry of the collector. The geometry of the collector will give you the thickness of your fiber. Like for example, if you have a small thin hose, you have a small thin tube, what happens to your output? If you have a larger diameter tube, what happens to your output? So all these parameters will influence your nanofiber morphology. Next, the critical parameters will be the temperature. So always when the temperature is going to increase, you're going to have more efficient reaction. In certain cases, obviously there are exceptions. Then you have thinner nanofibers. And the humidity. The humidity, if it is lower, you have a higher flow rate, and you have like these beads are like sort of the fiber is not flowing properly. The fiber is not coming out properly. So you have some agglomeration. So what happens when the humidity becomes low, you have a better flow rate. Okay. The next one here, this slide, which give you an idea about how the electrospinning itself will take place.
Electrospinning is an established technique for the manufacture of fibrous components for medical devices. During electrospinning, a syringe pump feeds a viscous solution through a needle, which is connected to a high voltage, ejecting a thin jet of the solution. The jet accelerates towards a target collector, held at an opposite potential, and thins considerably during flight. Dried fibers are then deposited as a non-woven mat, with each fiber being about 10 to 100 times thinner than the width of a human hair. Electrospun fibers can be used as simple mats and cut to shape with fibers of random, aligned, or layered orientation. The technique also allows for the coating of complex geometries and the manufacturing of specific structures like tubes. Different polymers can be used for this process, and devices can have an opaque or transparent appearance. The Electrospinning Company is a global leading manufacturer of electrospun biomaterials for medical devices. It can be used in a variety of clinical applications.
Yeah, this give you an idea about how these nanofibers are spun as well as in certain applications, medical applications, yeah? Now, basically, what applications, as I told you in the beginning, here you have the medical application, which is suitable for your area. You have tissue engineering. Then in food industry, it can be used for food processing and packaging. In the water and environment industry, ultrafiltration, desalination, water treatment applications. Electronics application can be sensors, LEDs, photodetectors. Then in the defense application, you have protective clothing. And energy applications, you have, like now the whole scenario is about fuel, green fuel. Green fuel is nothing but your hydrogen generation, where these nanoparticles or nanofibers will play a very, very important role. Now, what are the applications? I'm just giving you a brief of everything. Your nanospun fibers can be used for biomedical application, advanced drug delivery application, and then you can have energy application. In energy application, you can have fuel cells, hydrogen storage, lithium-ion batteries, all this. Then military protection applications, clothing. This is very, very important for the soldiers, okay? So you have like chemicals, anti-biochemical gases, electromagnetic shielding. Then you have electronic devices. Then nano sensors. You can have fluorescent sensors, biochemical sensors, and you can have thermal sensors. Environmental protection applications can be, again, the filtration media, like how you, like sometimes in certain, like even food, you have certain metal ions which are present, which are not the applicable level for human consumption. So to check on that, like for example, this example is very important, like for play toys. We buy a lot of play toys for the children, but we do not know the play toys itself will consist of limits of metals which are not, like for example, if the child or the baby is going to put it in the mouth, what is going to happen? Okay, though it is a very meager extent, it can have influences on the child's health, not immediately, but maybe at a later stage. Okay, so these are the main applications of your nanofibers or nanomaterials in general. Yeah, what happened? Anything? Dr. Nayaz, are you there?
No, nothing, ma'am.
Because
Once
it
again,
says the host
no,
muted.
something.
Now
Sorry,
it's
my
okay.
mistake. By mistake. Sorry, ma'am. Sorry.
Okay. So the water treatment application, you can have this. These are the main applications. You have adsorption, heavy metal adsorption. You have electrochemical degradation. That also can be removed using a nanofiber or a nanofiber mat. Again, the property of surface area. Then this is going to remove contaminants. You can even contaminate the water. Organic contaminants can be removed. Then you can have desalination, membrane distillation. All these are where polymer matrices or nanofibers are used in, like mainly like Gulf countries, Arabian Sea. We use that water for desalination. Desalination is the main source here of water. So all these are combined together, and the latest application is this oven mats, which are used for the removal of metals or carbonates or hardness, anything you can talk about. Okay, so this is a brief introduction about the electrospun nanofibers. It can be used in desalination. It can be used for nanofiltration, reverse osmosis, forward osmosis, membrane distillation, and capacitive deionization. So these are the various, I'm just giving you a glimpse of everything because I still have another 14 slides to go. Doctor, is the time okay? Can I continue?
Please proceed, ma'am. No issues. Please proceed.
Okay, yeah. So the only disadvantage of using these applications, that is the nanofibers, is there's an issue with the large scale production. and the disposal, the nanofibers. These two are the criteria of research which is going on recently. And the efficiency, the regeneration efficiency, the recyclability, and all these are, again, there are a lot of, even in trace concentrations, you can remove this. These two are the areas which you need to be focused on for the application, water treatment applications. The air filtration application, you can look at the video here.
Nanofiber technology holds great promise for disrupting the air filtration industry by enabling a new level of filtration performance. Nanofibers are about 1,000 times thinner than a human hair, so they trap the smallest airborne particles. Their large porosity enables excellent airflow and reduced pressure drop. Electrospinning, as an advanced nanotechnology for processing nanofibers, has gained wide attention by virtue of its capacity for large-scale production of nanofibers with controlled structures from various materials. The process allows the nanofibers to be functionalized with active ingredients in a single manufacturing step, resulting in a filter media that not only traps, but destroys airborne bacteria and viruses. Today, most air filtration media are made of non-woven microfibers, which have a low initial filtration efficiency due to their large pore size. Electrospinning nanofibers on these media can greatly improve their filtration efficiency without significantly increasing their pressure drops, offering the opportunity for developing more effective, scalable, and affordable air filters. The rolled filter media is easily included into your manufacturing steps, cut and pleated to be a layer in a filter of any shape and size.
Yeah. Next is the application. So far, you have seen what is maybe applicable to you all as a life scientist, or as a biologist, or as a chemist. So now the electronics application. Yeah. Now the energy storage application, for example, the graphitized carbon nanofibers are used in electronics applications. Now you know this, electric vehicles. This is what is the next scenario now recently. So here you have supercapacitors. You can have the batteries. You can have lithium sulfur batteries, lithium ion batteries, the hydrogen production. In all these areas, again, the same, the electrical conductivity, the large surface to volume ratio, the structural stability, and high aspect ratio make these materials suitable for all these applications. It can be used in electrode reactions or electrocatalysis. It can be used as a catalyst. Then electrochemical energy storage, it can be used. That is what are all these applications. Then you can use for electrode materials and conductive additives. Additives are nothing but substances which are added, like for example, the tire, the carbon black is the additive of the tire. That's the simplest way of example. Like for example, the tires are not generally black, but because of this carbon additive that is added, carbon black additive that is added, anything that is added to improve the properties during the manufacture stage. That is the meaning of an additive. Now you have all these. What are the developments in this carbon nanofibers? In carbon nanofibers, you have the fabrication process. The fabrication process along with the precursor and the dopants, the co-catalyst, all these will improve your properties. Like for example, all these applications, your graphite nanofibers are used in all these electronic applications. Now coming to your biomedical fibers or my biomedical applications, how nanofibers are used. You have drug delivery, you have wound dressing, you have biosensors, you have tissue engineering. So in all these areas, your nanofibers can be used. What is the positive about this? It is biocompatible. That is and the other properties are very much similar with the electronics application. The nanofibers, you have easy methods of preparation. You can adjust your features. That is what I was telling you. You can tailor make your properties and you can adjust the elasticity depending on the kind of application you need. Like for example, wound healing, the healing stages will be the hemostasis. Then you have the inflammation, all these steps, your wound dressing, all these also, your bandage, your plasters, or any other like the medical application. So these are the characteristics when you're using a nano mat or a nano bandage, a nano material or a nano fiber, which is included. See, it absorbs excess exudate, prevents infection, it keeps the moisture of the wound side, and the ease of exchange of gases. It is biocompatible and biodegradable. It does not stick onto the wound surface. And it also, these two are the last three stages, angiogenesis and tissue remodeling is what you need after your wound gets like in the stages of process, like when it's becoming better. When your wound becomes better, probably after a week or something. So your wound healing mechanism works very well with nanofibers. Similarly, the drug delivery. Drug delivery, again, like biomedical application, where you need the drug to be released very fast or very slowly or in a biphasic mode or in a stimulus act, depending upon the pH change, you need the drug delivery to take place. All these are these applications or the way it is being done is more efficient when you're using the drug that is loaded with a nanofiber. Like the drug loading applications, you have advantages. The advantages here are basically that you have increased solubility and degradation. And then you have chemical immobilization, you have physical adsorption. All these are the various methods of drug loading. So now, basically, what are the polymers that can be used here? You can have polycaprolactone. You can have polylactic acid. I'm specifically saying only certain ones which are biodegradable. Okay, then you have the chitosan. And these are all the commercial or the synthetic polymers that can be used. So in all these drugs, like for example, anti-inflammatory class of drugs, anti-cancer drugs, like what is kind of electrospinning method is used, the electrospinning method is used, and what are the applications? Any biomedical application or any medical application you have, the use of these class of materials, that is the polymers and the nanofibers, can be used as in, like for example, in these drugs. So biosensor application, again, here data acquisition, the transducer, and then the sensing layer. Here you have biomolecules immobilized on the surface of the nanofibers. So here you have biorecognition element, you have a transducer element, and you have a signal capture element. This is how the biosensor works. Then the solar cell application, again, not much applicable to you, but just to have an idea of what it is. Again, here you have the electrospun fibers, which are used for energy conservation, and the conductivity is a very important parameter along with the surface area. So the overall performance in this will not have any adverse effect on the environment. So if you see these layers, all these are electrospun layers for solar cell applications. What are the challenges? The challenges depends upon the type of application. The pore size sometimes may be too small, or sometimes here, this again depends upon what you need and what kind of application you're using. And the next is what kind of polymers that are going to be used. And again, the biodegradability parameter will come in. So here the pore size, the mechanical strength, and then the degradation of the nanofibers and the industrial fabrication. All these pose challenges, though it is being used to a much greater level now than before. So in order to conclude, I would like to say that these are the polylactic acid-based nanofibers. Okay, these are your applications in packaging. These are the advantages. Anything, any nanomaterial will have a porosity application, which has a barrier property, the thermal property, the mechanical property. And what are the electrospinning types? You can use monoaxial spinning, you can have coaxial or emulsion, and you can have any other type of spinning. Here, again, the wound dressing application, the scaffolds, the tissue engineering, the protective clothing, all this will come under the medical application. It can be used as a catalyst, sensor, energy storage, solar cells. The filters is for water applications. Sorry. And then again, here, the pore size of the material also can be electrospun fibers, again can be used. It's a repetition here. It's just to conclude that energy storage, the sensor application, flame retardant clothing material, the sound absorption, the oil adsorption, the separation, and biomedical applications can be used. Now, the next, just to conclude, this is what relevant to your area is all this. The tissue engineering scaffolds, wound dressing, medical applications, hemostatic devices, the drug delivery, cosmetics, the sensors devices, all these are for other areas, filtration, and the electrical conductor application. These are some of the references which I have referred to have this talk. I would like to thank Dr. Niaz and his team for having invited me. And thank you once again. Any questions you can ask me. Thank you once again.
Ma'am, good morning, ma'am, and good morning to all. Myself, Satya, Professor, Department of Pharmacognosy from Adiparashakti College of Pharmacy.
Yes.
I have some doubts, ma'am. May I ask you, ma'am?
Yeah, sure. Whatever extent which I know, because I'm a chemistry background, whatever
yes.
extent which I know, I can tell you.
This is actually very nice and useful presentation, ma'am, for pharmacist. So thank you so much, ma'am. Ma'am, may I know the ambient conditions, the temperature and humidity, ma'am, for production of this nanofibers?
No, that depends upon the kind of your material selection is important.
Okay, ma'am.
Okay, it depends upon the material selection, and depending upon, you have different electrospinning devices now.
Okay, ma'am.
Two things. So this, like your temperature, your current, and the way it is spun, and the kind of solvent, because when you mix two polymers together, the kind of solvent which you're using also will have an effect on all this.
Okay,
the spinning efficiency depends upon the material.
Okay, ma'am.
Yeah.
Okay, ma'am. Ma'am, is the desalination process, ma'am, is it possible to convert seawater to safe drinking water, ma'am?
It's not exactly safe drinking water, but though the hardness is a little more in the, like for example, the Gulf countries, we don't use the tap water for drinking, unlike US and UK where they use the tap water for drinking. But like that water which comes in our tap, we use for cooking.
Okay, ma'am.
So the desalination process is there. That's the way they get normal water here itself, because groundwater it's a desert, right? So groundwater, we don't have much. Unless otherwise it's in the outer of the city, not exactly in the city. So outer Muscat, outer Oman, we can have some groundwater. But basically here, they use desalination, and the desalination water which comes, we are using in the tap. Though not 100% used for drinking. We use the can water here.
Okay, ma'am. Yes, ma'am. Ma'am, is this nanofiber is applicable for natural products, ma'am?
Yeah, natural product, yes. But
is it possible to make a formulation using herbal drugs, something, ma'am?
Probably you can do your research out of it.
Yes, ma'am. Yes, ma'am.
Yeah. Because the bioregulatory choice and all depends upon the kind of material which you're choosing.
Yes, ma'am. Yes, ma'am. Ma'am, your contact details, please, ma'am. So in future.
Dr. Niaz knows, no, I'm from Muscat.
Yes, ma'am.
I'm working here for quite some time, University of Technology and Applied Sciences. I'm here for the last 15 years. So anything you can email me, nalini.ramachandran utahs.edu.oman. Probably I can share it in the chat if you need it.
Yes, ma'am. Yes, ma'am. Sure, ma'am.
I will share in the chat box, ma'am. I will
Yes,
share
sir.
in the chat
Yes, sir.
box.
Thank you so much, sir.
Satya, ma'am, I will share the thing,
Yes, sir. Yes,
your
sir. Sure, sir.
WhatsApp group also for you can contact.
Yes, sir. Sir, thanks to
Mine is
your
smaller.
institution, sir.
Thank you, ma'am. Thank you, ma'am.
Thank you so much,
Thank you,
ma'am.
Dr. Nalini, ma'am. Thank you,
Yeah,
Satya,
thank you
ma'am.
very much, sir.
So,
Thank you, sir.
yeah. Yes, due to shortage of time, ma'am has class today. That's why intentionally not put the queries you can write in the chat box like that. But I feel happy due to curiosity, ma'am. If audience are asking questions from my, it is not a formal vote of thanks. From my bottom of heart, I would like to thank Dr. Nalini, ma'am, for accepting our invitation in the short span of time. As the Satya ma'am asked some question, I too happy and listen to polymer nanofiber related. I am also curiosity in the chitos and biocomposite. I would like to ask some question, but due to short of time, your lecture tell us about the love to the subject. Even though while I am talking with ma'am, Nalini ma'am planned to give the lecture 20 minutes, but her love to the subject expertise, it goes on. When I'm searching for the international scholar, my college colleagues suggested me about ma'am enlighten us in the last year, in the year of 2023. Ma'am gave a lecture. It was good feedback. With this formal vote of thanks, I would like to thank our speaker for her availability and enlightenment. Thank you, ma'am. Thank you.
Thank you very much, sir. Thank you, sir. Thank you.
Ma'am, I will share the YouTube link to your WhatsApp, ma'am. Thank you.
Yeah, okay. Thank you, doctor.
Thank you.
Yeah, thank you.
Thank you,
Yeah.
Dear audience, now we can proceed with students' presentation. So, Pavitra ma'am is there? Pavitra ma'am? Dr. Ma'am is there, ma'am is there. Dr. Pavitra from DG Vaishnava College. Ma'am is the jury for today's session. Pavitra ma'am?
Yes, sir. Can you hear me, sir?
Yes, sir. Good morning, sir.
Good morning, ma'am. So let us, as the jury joined with us, we can start the student presentation. Kindly note others.
Shall I start, sir?
One second, ma'am. So Dr. Pavitra M is a distinguished academic and researcher. She is the jury of the day. Currently, ma'am is serving as other kindly switch off your audio and video. Pavitra ma'am, I got some external noise. So, ma'am is a distinguished academic and researcher, currently serving as assistant professor in the Department of Biotechnology at Dwarka Das, Govardhan Das, Vaishnava College, Chennai, with a PhD in biotechnology from VIT University, where I also did my postdoc. She specializes in microbiology, molecular biology, agricultural biotechnology, and animal biotechnology. Dr. Pavitra has over 9 years of academic and research experience, complemented by a prolific publication record, including several book chapters and authored books. Ma'am is a recipient of multiple awards, including the Research Award from VIT University, one of the topmost private university, and has been recognized as an external examiner for reputed universities. Her expertise extends to nanotechnology, molecular docking studies, and microbial research. Additionally, she is an accomplished poet, a district-level hockey player, and an award-winning Bharatanatyam dancer, with spiritual and motivational speeches enriching her multifaceted profile. With this short bio, I would like to welcome our jury of the day, Dr. Pavitra, to hand over the session. Pavitra ma'am, you can proceed, ma'am.
Thank you, sir. Good morning, ladies and gentlemen. It is a great honor to join with you all today as a jury member for the esteemed Virtual International Conference on Innovation in Life Sciences, organized by the Institution Innovation Council of Sacred Hearts College, Tirupattur, in collaboration with Agar, Andhra Pradesh. I would like to begin by extending my heartfelt gratitude to Dr. Niaz Ahmed for inviting me and providing this wonderful opportunity to be a part of such intellectually stimulating event. Before we proceed with the presentations, I would like to take a moment to express my admiration for the enlightening lecture delivered by Dr. Nalini. Her insights were truly thought provoking and provided a profound perspective in the applications of nanotechnology. Such depth of knowledge is both inspiring and invaluable for all of us here today. To all the participants, I warmly welcome you to this paper presentation session. It is inspiring to see so many bright minds gathered here in the Zoom meeting, eager to share their research ideas and innovations. This platform not only celebrates academic excellence but also fosters collaboration and exchange of knowledge that transcends borders. I look forward to engaging with your work and learning from the depth and diversity of your insights. Let us make this session a fruitful and enriching experience for everyone involved. Thank you and best wishes for all the presenters. Now I'll call upon the first presenter. The first presenter will be Dr. K. Shobha from DKM College of Women. Dr. Shobha, are you here, ma'am? Dr. Shobha from DKM College.
Ma'am, I think Shobha ma'am is not.
Okay, the next presenter.
Present.
Yeah, the second person is Sarika Pillai from Pasteur Institute of India, Kunur.
Good morning, ma'am.
Good morning, Sarika.
Ma'am, shall
Please
I
go
share my
ahead.
screen?
Yeah, please share your screen and start presenting. Your time
Okay.
limit will be 4 minutes. Kindly stick
Okay,
to the
ma'am.
timings.
Sure, ma'am. Ma'am, is my screen visible?
Yeah, visible.
Okay, ma'am. Good morning, everyone. I'm Sarika Pillai, PhD scholar at Pasteur Institute of India, Kunur, doing PhD under the guidance of Dr. S. Jagannathan. And today my presentation is related to the CAP study that I have done as an initial work of my PhD research work. It is about bridging knowledge, attitudes, and practices to strengthen awareness and control of Castanor forest disease. Castanor forest disease, often referred as monkey fever, is a tick-borne viral illness primarily affecting humans and monkeys. It was first reported in Shimoga, Karnataka in the year 1957, and it has now spread across the Western Ghats including Kerala, Tamil Nadu, Goa and Maharashtra. With no specific treatment available, KFT poses significant challenges, including a case fatality rate of 3 to 5% as per the CDC. The existing CEF vaccine has low acceptance due to its long dosing regimen and painful administration. In this context, understanding public knowledge, attitudes, and practices becomes crucial for effective control of KFT. So, in this CAP study, the 4 primary objectives that I focused was to assess the public knowledge about KFT, including its symptoms, transmission, and prevention, understand community attitudes such as the level of concern and trust in prevention measures, evaluate current practices adopted to prevent KFT, including vaccination and personal protection, highlight the gaps and barriers to inform actionable recommendations for policy and interventions. So in this study, I've employed a structured questionnaire designed to capture diverse aspects of KFT awareness and behaviors. So I've used the Google Forms and I've collected the responses from 235 participants representing a variety of age groups, educational backgrounds, and geographical locations across the Western Ghats. The survey included multiple choice questions covering knowledge, attitudes, practice, and the sources of information. The participants in our survey were diverse, spanning a range of age groups from 18 to 65 and educational qualifications. Most respondents resided in or near the forested regions prone to KFD outbreaks, ensuring that our data reflected the perspectives of at-risk communities. When assessing knowledge, we found that awareness of KFD's existence was limited, especially in certain regions. Many participants had misconceptions such as confusing KFD, since it is known as monkey fever, confused with the monkeypox, likely due to the overlapping symptoms like fever and rash. Furthermore, knowledge about KFD's transmission cycle primarily via the tick was low, with some believing monkeys were the direct source of infection. The finding highlights a need for improved communication strategies to address these misconceptions and emphasize accurate sources of information. Coming to the attitude towards KFD, while many acknowledged it as a serious health threat, others displayed indifference, likely due to the misinformation or lack of direct exposure. Respondents viewed public awareness campaigns as moderately effective but expressed a desire for more localized and actionable initiatives. Encouragingly, community participation in control efforts was seen as important, though cultural and religious beliefs sometimes acted as barriers. Understanding and addressing these attitudes are vital for improving preventive measures. When it comes to the preventive measures, our findings were concerning. The use of tick repellents and protective clothing was inconsistent, often due to lack of awareness or access. Vaccination rates were disappointingly low, with many expressing hesitancy due to doubts about efficacy and fear of side effects. Some participants relied on traditional medicines, which, while culturally significant, lacked scientific validation. Addressing these barriers and promoting evidence-based practices are key to reducing the spread of the disease. So this is the result that I've got from the forms response. To summarize, the study identified several critical gaps. The low awareness among the people, especially in certain regions, the prevalence of misconceptions about disease transmission, significant gaps in preventive practices, including vaccine uptake. So these were the things that needed urgent interventions. So in the graph itself, we can see that only 58.2%, only 41.8% were aware about KFD and 58.2% were unaware of KFD, the monkey fever. So this is the place where the KFD is affected. So you can see all across the Western Ghats. First it started from Karnataka and now it has spread to till Gujarat. So the primary barriers that we identified was ineffective awareness campaigns that failed to reach vulnerable populations, and people were unaware that what is the mode of transmission and how we can control or prevent the spread of the diseases. There were many graphs, and since there is time constraint and I cannot, there was a limit for the number of slides that was included, I've reduced the number of responses here in this findings. So based on our findings, the low awareness levels, particularly in certain regions, so that needs to be filled. The primary barriers that were identified was ineffective awareness campaigns that failed to reach the population, the limited access to vaccines, both geographically and economically. There was a vaccine that was given to the people till September 2022, and now the government has discontinued the usage of the vaccine. So currently there is no vaccine. Reluctance to adoptive preventive measures due to misinformation and cultural resistance. So based on my study, the recommendations that I found out was to enhance public awareness campaigns to address misconceptions and improve outreach, increasing vaccine accessibility and encouraging uptake through community health programs, strengthening health systems to provide accurate information and resources, encouraging community involvement, fostering trust, and promoting ownership or preventive efforts. So the role of health authorities also play an important role. Disseminating clear, accurate information to counter misinformation, conducting regular community outreach programs to promote preventive measures, strengthening local health infrastructure to support vaccine distribution and awareness. The impact of education is also playing an important role. Educational institutions can significantly contribute by including vector-borne diseases like KFT in curriculum to build awareness among students, because when we were doing the survey, we have taken the information and collected the information from medical colleges, then other UG and PG colleges. Being a medical background course also, the students were unaware about the diseases. So what I feel is to organize awareness programs in high-risk areas to empower communities with knowledge. Education is a powerful tool, and we know that if the educated people, if there is a gap among the educated people, we can think about the illiterate people. So in conclusion, tackling KFD requires collaborative efforts among health authorities, educational institutions, and communities. Sustained engagement backed by robust policies and targeted interventions can pave the way for a KFD-free future. So despite some level of awareness, significant knowledge gaps and misconceptions remain. So addressing these gaps is critical for effective disease prevention. Attitudes play a crucial role in determining the success of preventive measures against KFD. Participants acknowledge the importance of community involvement. There is a pressing need to address the misconceptions and the critical gap between awareness and action in KFD prevention. That also plays a major role. Some participants adopt preventive practices, others face barriers such as misinformation, lack of resources, and low vaccine confidence. So, coming to the conclusion, thinking about all these data that I have obtained, the research highlights a significant gap in the public awareness, attitudes, and practices related to KFD, particularly misconceptions and transmission and low adoption of the preventive measures like vaccination and the tick repellent methods. So what I feel is that there should be improved vaccine accessibility and community involvement is needed to bridge the gaps. Collaborative efforts among health authorities, educators, and local communities are essential for fostering sustainable preventive practices and reducing the risk of transmission. So I wish to express my sincere gratitude towards the director, PIIC, then Dr. Sumita, my external expert, HOD KC Shivanandappa, Dr. S. Jagannathan, my guide, and Dr. Paramashivan Rajaya for supporting me. Thank you so much.
Thank you, Ms. Sarika. That was a nice presentation. Can you tell about what kind of technology can be used to improve the early detection and management of KFD outbreaks?
Ma'am, there are, regarding the early detection, currently NIV Pune has developed a kit for the detection, the surveillance kit for the detection, the point care kit. So it was developed by NIV and it is practiced in those endemic areas, especially in Shimoga, Kerala's Wayanad, and Tamil Nadu Nilgiris.
Okay. Do you find any current gaps in research about KFD?
No, as of now, there was gap, but the thing is, nowadays people are focusing more on the neglected zoonotic diseases. So if we see the last 5 years, we can see that there are many researchers which is coming on the same KFD. And specifically, since the efficacy of the vaccine was proved that it was around 68%. So people are trying to develop new vaccine techniques, and my research work is also on the same.
Okay. Thank you, Sarika.
Thank you, ma'am.
The next participant will be Mr. G. Venkataswamy. Sorry, it is Mr. R. Raman from Venkataswamy College. G. Venkataswamy Naidu College. Mr. R. Raman. Are you
Good
here?
morning. Yes,
Good
ma'am. Good morning. ma'am.
Yes, you can please share your slide and start presenting.
Okay,
Kindly
ma'am.
stick to
Thank
the
you.
timings.
Okay, ma'am.
Okay. You have just 4 minutes.
Okay, ma'am. I'm sharing the screen, ma'am. Ma'am, is it visible?
No.
Oh. Please wait, ma'am. Now is it visible, ma'am?
Yes, I could see your screen alone,
Ma'am?
not the PPT. You're
Hello?
presenting from phone.
Hello?
Yes, Mr. Raman, you're presenting from your mobile. Mr. Ram, can you hear me?
Visible now? Ma'am?
Yes, Raman.
Raman, your side you have
Ma'am?
connectivity issue also.
Sir,
Pavitra ma'am,
now,
can you
shall I
move?
call the next participant, sir?
Yeah, yes, please.
Yes. Ms. Rama Devi from KL Deemed University, Guntur, Andhra Pradesh. Ms. Rama Devi, KL Deemed University, Guntur. Ms. Rama Devi, I'll go for the next participants if you're not available. Dr. Vino,
Yes, ma'am, please.
Dr. Vino from PSGR Krishnambal College. Dr. Vino from PSGR Krishnambal College. Ms. Soundarya from DKM College. Ms. Soundarya, are you here?
Yes, ma'am.
Can you present?
Yes, ma'am.
Yes, please share your screen.
Ma'am, is it visible, ma'am?
No. Ms. Soundarya, if you have any joining issues, can I call the next participant?
Okay, ma'am.
Dr. Jnanendra Kumar. Dr. Jnanendra Kumar, National PGC College, Lucknow. Dr. Jnanendra Kumar from Department of Zoology, National PG College, Lucknow. Dr. Vinayaka from Sri Venkatramana Swami College. Dr. Vinayaka. Dr. Vinayaka. Miss Arshia Begum from Sacred Hearts College.
Yes, ma'am. Good morning, ma'am.
Morning, ma'am. Can you please present?
Yeah, sure, ma'am.
Try to share your screen.
Ma'am, can you wait for a second, ma'am?
Yes. How long should I wait? I'll call the next member. Mr. Shaktivel from Sacred Hearts College. Mr. Shaktivel, are you here?
Hello, ma'am. I am Shaktivel, ma'am.
Yes, Shaktivel, can you share your screen and start presenting?
Yes, ma'am. Okay, ma'am. Ma'am, I can visible, ma'am. My slide.
No. Shaktivel, can you share? You have any issues in sharing?
Ma'am, can you move on to next participant? Ma'am?
Mr. Tamar Selvan from Sacred Hearts College. The next participant, Mr. Tamar Selvan.
Yes, ma'am, I am here.
At least you can try.
Sure, ma'am. Wait a second, ma'am. I just opening my file. Ma'am, now it's visible, ma'am.
Yes, it is visible. Change the orientation. Just
Shall I start, ma'am?
make the screen wider. Tilt your mobile.
Yeah, ma'am. Now it's okay, ma'am.
Yes, okay.
Okay. Good morning to all. I am Tamil Selvan from Sacred Hearts College, PG student of biochemistry, ma'am. My topic about green synthesis of iron oxide nanoparticles by using mixture of citrus fruit seeds. Iron oxide nanoparticles play important role in environmental remediation and circles, and there are several chemical and physical methods available of synthesis of iron oxide nanoparticles. Synthesis of iron oxide nanoparticles by using plant extract been quite limited and few works of has been reported. They reported as available for synthesis of iron oxide by ferrous sulfate by thermal decomposition and iron nanoparticle by using mixture of orange seed and grape seeds extracts. Fruits of citrus from family Retusia and the wild juice and pulp commonly utilized and seed are often discovered deposit being the reservoirs of visible secondary metabolites such as flavonoids, alkaloids, and polyphenols. Recent studies highlight the potential iron oxide nanoparticle by using mixture of citrus seed extracts, antibacterial and antioxidant applications. These are the iron or orange seed and black grape seeds are I taken in my samples to use the extract sample powder and the historical usage of citrus. Citrus foods of long history and use of traditional medicine and the bioactivity of components of phytochemical analysis to polyphenols, flavonoids, notes, alkaloids, and essential oils, and environmental sustainability. Utilizing the citrus seed typically discard as a waste and aligns with the principle of circular economic and sustainable resource management. Objectivity in the current study, we reported that the characterization studies and the activity looked on the extraction of mixture of my samples and iron oxide nanoparticles. What are the activities are following steps? Phytochemical extraction method to my extraction of sample seeds and to analyze the characterization studies for nanoparticles, UV, FTIR, and SIM, and to examine the antibacterial activity also and also antioxidant activity. So phytochemical composition of mixture of seeds, flavonoids, phenolic acid, lymph nodes, and essential oils. The key contribution of antioxidant activity is flavonoids, and the known as the antimicrobial properties against a range of bacterial pathogens, the phenolic acids, and lymph nodes exhibit the potent bioactivity, include anti-inflammatory and antimicrobial effects. Essential oils contains terpenes and other aromatic compounds that enhance antibacterial efficiency. Characterization of iron oxide nanoparticles. Various characterization techniques to determine the size, shape, surface of morphology, and other properties. Some commonly used techniques included to uh, scanning electron microscope, UV visible spectroscopy, and FTIR. Scanning electron microscopy to provide a detailed image of surface of morphology on iron oxide nanoparticles. UV visible spectroscopy is used to optical properties of iron oxide nanoparticles. FTIR to analyze helps to identifying the functional groups of resultant surface of iron oxide nanoparticles. And these are the applications, cosmetic industry applications, pharmaceuticals, applications of animal feed, natural cleaning product, veterinary medicines, cosmetic industry applications. Sorry, ma'am. Citrus seeds, oils, and extracts are valued of cosmetic industries, skin nursing, and anti-aging properties. Pharmaceuticals, citrus seed phytochemicals have been shown promising results of developing antimicrobial and anti-cancer agents. They have to conclude the mixture of iron oxide nanoparticles hold on potential antibacterial and antioxidant agents, offering sustainable and natural alternatives of various industries. The integration of iron oxide nanoparticles to pharmaceuticals and cosmetic products aligns to global trends towards sustainability and the natural products. The finding on the antibacterial and antioxidant activities of iron oxide nanoparticles underscore the significance potential of addressing global health and industrial challenges. Thank you, ma'am, and thank you, sir. The wonderful opportunity to present in here.
Why did you choose oil seed and grapeseed extract for synthesis? Are they more effective compared to other plant extracts, or how special they are?
I'm sorry, ma'am. First, not hear your voice, ma'am. I can't understand.
Can you
Once
hear
again,
me
please.
now? Can you hear
Yes,
me
ma'am.
now?
Yes,
Okay. So why did you select orange seed and grape seed? Why not other plant extracts?
ma'am. I select of citrus, ma'am. Citrus fruit, especially of citric acid. So I again, and I not to compare to orange seed and grape seed separately. I have to mix the seed samples and the extract to nanoparticle because of more potential to give the two seeds of mixtures, ma'am.
Okay. Did you add any stabilizer to the plant extracts, or the plant extract itself was having the stabilizing agents?
Stabilizing agents.
Did you add any additional stabilizers to the reaction?
No, ma'am.
No?
Yes, ma'am.
Okay. Thank you, Tamachelvan.
Thank you, ma'am.
Thank
I
you.
stop my presentation.
Yes, yes, please stop. And next, I would call Mr. Raman from Venkataswamy Naidu College. Raman, are you ready?
Yes, ma'am. Ma'am, am I audible?
Yeah, you're audible. Please share your screen.
Okay, ma'am. Is it visible, ma'am?
Yes.
Okay. Thank you, ma'am.
Please start.
Good morning, everyone. My topic is new class of functions in nano-topological spaces. I am Raman, research scholar in GVN College Mathematics from Kovilpatti. And I'm doing research under the guidance of Dr. S. Bias Messier, Department of Mathematics, Don Bosco College. My joint supervisor is Dr. E. Susila ma'am from GVN College. The purpose of the research paper is to introduce a new notion of functions in nanotopological spaces, which means nano strongly BC continuous and perfectly BC continuous mappings. Now,
Mr. Raman, your voice is
the
breaking in between.
study of nanotopology was initialized by Lellis Divagar with a subset of universal set, which is approximation space, lower, upper, and boundary approximations. And he additionally described nano interior closure in nanotopological spaces. Okay, ma'am.
Mr. Raman, I think you have some issues with internet.
Another, let us introduce.
Are you continuing?
Ma'am,
Yes,
am
Raman.
I audible?
Yes, you're audible, but your network is low. Your voice breaks in between. Please move to a place where you get nice internet. Where there is proper signal, you can move and press in there. If you need time, I'll call you later. Can I call the next participant?
Ma'am, my screen is visible.
Yes, go ahead.
Are you continuing? Visible?
Yes.
Yes, now, ma'am.
Your voice breaks in between.
Now, ma'am.
Now it's fine.
Now, is it clear, ma'am?
Where you get nice internet.
Okay. Sure, ma'am.
Mr. Raman, can you hear me?
Raman, you can present at the end, pa. Ma'am, can you call next, ma'am?
Yes, sir. It's taking time for him. The next presenter, Shaktivel, are you here? Mr. Shaktivel? Mr. Shaktivel? Miss G. Kirtana from Sacred Arts College. Miss G. Kirtana,
Yes, ma'am.
can you present? Do you have any internet issues or you're okay with your signals? Miss Kirtana?
Yes, ma'am. Is it visible, ma'am?
Ma'am,
No.
Now is it visible, ma'am?
Yes. Yes, Kirtana. Your screen is visible.
Good morning to all. I am Kirtana, Department of Biochemistry from Sacred Heart College. My topic is about zinc oxide nanoparticle. Zinc oxide nanoparticle plays an important role in recent years due to their unique physical, chemical, and biological properties, which make them highly applicable in a wide range of fields, including medicine, environmental management, electronics, and cosmetics. It is an extensively studied metal oxide nanoparticles due to their excellent properties, including their wide band gap, high surface reactivity, and remarkable antimicrobial effect. These nanoparticles are composed of zinc and oxygen atom, which forms a crystalline structure that can vary between hexagonal, cubic, and other polymorphs. Zinc oxide nanoparticles have high optical transparency, UV blocking ability, and photocatalytic properties, which are desirable in various applications such as drug delivery systems, sunscreens, and sensors. Their ability to generate reactive oxygen species ROS upon exposure to UV light makes them effective in breaking down and harmful pollutants in air and water were extracted. The wide availability of raw materials of the synthesis of zinc oxide nanoparticles and the relatively low cost of production make them an attractive choice for large scale applications. This zinc oxide is biocompatible and non-toxic at low concentrations, which increase its sustainability for use in biomedical and consumer products. These are the zinc oxide nanoparticle. Zinc oxide nanoparticle can be synthesized by various steps determining their size, shape, and overall properties. Some of the most commonly used synthesis methods are chemical preparation, sol gel method, hydrothermal synthesis, and green synthesis. Zinc oxide nanoparticle can be characterized by their shape, size, surface morphology, and other properties. Some commonly used techniques are scanning electron microscopy, SEM, X-ray diffraction, transmission electron microscopy, UV visible spectroscopy, and FTIR. Applications of zinc oxide nanoparticle. This zinc oxide nanoparticle are utilized in various fields due to their unique and beneficial properties. Some key applications are medical and pharmaceutical application like antibacterial and antifungal activity, drug delivery system, cancer therapy. Cosmetic and skin care like UV protection, skin treatment. Environmental applications like water treatment, air purification. Toxicity and safety concerns like cytotoxicity, environmental impact. Conclusion, this zinc oxide nanoparticles have played a unique role in physical, chemical, and biological properties, which make them highly applicable in a wide range of fields, including medicine, environmental management, electronics, and cosmetics. This nanoparticle exhibits a large surface area to volume ratio, high chemical stability, and excellent antimicrobial properties, making them a valuable material in various industrial applications. This zinc nanoparticle aims to explore the synthesis method, characterization techniques, applications, and the potential benefits and challenges of using zinc oxide nanoparticle in different industries. In addition, to discuss the toxicity concerns and the need for careful handling and safety protocols for their users in consumer products. Thank you, ma'am. Ma'am,
Your questions are like, I'd like to ask, what are the unique properties of zinc oxide nanoparticles while it is used in applications like cosmetics, sensors, or antimicrobial agents? So you spoke about antimicrobial agents, right?
yes, ma'am.
Yeah. Can it be used in cosmetics and sensors also?
Yes, ma'am.
Okay. So which synthesis method did you use for preparing zinc oxide? Have you started your work on zinc oxides or you're just learning what it is?
Started, ma'am.
Okay. Okay. How did the particle size and morphology impact the functionality of zinc nanoparticles? The particle size, and if it is small, how the function will be, and if the particle size is big, how the function will be. You have any idea on that?
Ma'am,
About the particle size of zinc nanoparticles, do you have any idea on it?
yes, ma'am.
Yeah, tell me then how the function and the particle size is related. No? Kitna? Okay, so I call upon the next participant. Thank you, Kirtana. Ms. Shreya from Dr. Mahalingam College of Engineering and Technology. Ms. Shreya, are you here? Ms. Shreya?
Am I audible, ma'am?
Yes, you're audible. Can you share your screen, Shreya?
Yes, ma'am. Is it visible, ma'am?
Yes, it is visible, Shreya. Please start. And your time limit is 4 minutes. Already we are running out of time.
Yes, ma'am.
Please be short and sweet.
Okay, ma'am. Good afternoon, everyone. My name is Shreya. I'm currently pursuing my BE in Computer Science Engineering in Dr. Mahalingam College of Engineering and Technology. Today, I'm going to present on the topic application of multimodals in genomics. So multimodal approaches in genomics integrate diverse data types such as genomics, transcriptomics, proteomics, and clinical data to provide a comprehensive insights into biological systems and diseases. This integration can enhance target identification, drug delivery, and personalized medicine, providing and accelerating research and improving therapeutic outcomes. What is multimodal and genomics? Multimodal is an artificial intelligence and machine learning concept which uses diverse data types to train the models, process the information, and to solve problems, where in which we use multiple data modalities. Each modality provides a unique information, and when we integrate all these models, we could get optimized a single modality. So in the context of genomics, we use multimodals like we use multimodals like genomic sequences, transcriptomics, epigenomics, proteomics, and phenotypic information. All these are different kinds of data about the genomics, which will be useful for many predictions. So, what is genomics? We all know that genomics is the study of entire genome, including structure, function, and evolution. These are, as I've told already, these are the genomic modalities that we will be going to use in the models. And why multimodality is critical in genomics. Let's see the challenges of genomics. The first thing is complexity of biological systems. We all know that we all know the complex structures of DNAs, RNAs, and the proteins. To come into a conclusion, the data here is so complex. So that is the first thing. And the data heterogeneity, which is there will be different kinds of data available in different formats. So that will be difficult to format and proceed. The next thing is missing or incomplete data in single modalities. There might be some situations where some data will not be available. So these are the things. So how multimodality can help these help face these challenges is the interactive understanding. That is integrative understanding, which is we'll be coming to a conclusion from a wide range of data by training and processing and analyzing using the multimodals. And the second one is improved prediction accuracy. As it is trained with a large set of data, the outcome will be more accurate. And the last one is insights to gene environment interactions. As they are related to each other, it will give a more familiar outcome. So the technologies that will enable these multimodal genomics is, first we need data to train the models. So first we need to collect the data. We can do it by sequencing technologies like NGS and RNA sequencing, and we can collect the data from MRI and CT scans, and we can take the clinical records and the data from the wearable devices. From all these, we can collect the data. So the next step is computation. So we'll take all this data and we'll feed it into the models and train them. So we'll use AI/ML frameworks like transformers, CNNs, and GNNs. CNN is convolutional neural networks, and GNN is graphical neural network. And we can use bioinformatics tools to process the biological data. So with these, we can process all the data and come to a conclusion. We can predict the outcomes to a single one. So the last one is fusion methods. Fusion method is the process of integrating and combining data to enhance analysis, prediction, and decision making about the data that we have computed. The next one is workflow of multimodal data integration. In machine learning, we have different kinds of approaches, that is unsupervised, weakly supervised, and supervised, where first we'll find the features and we'll feed the data, and the computation takes place, and finally we get the result. In unsupervised learning, it is used for classification of data. Here it is given about an example of cancer. The next one is application of applications in multimodal genomics.
Can you move your slides fast?
Yes, ma'am.
Yes.
So this is the main part. The thing is predictive models. We can use multi-models to create predictive models that will be used for disease prediction, like cancer prediction and some rare genetic disease prediction. For that, it can be used. Then the second one is drug delivery. It is used to find the specific drug targets and the requirements. And the next one is functional genomics. We can find the functions and regulations between the DNAs, RNAs, and proteins. And the next one is personalized medicines. From the patient's clinical record and specific data about some patients, we can give precise therapies to that patients in a personalized way. So this is how the mechanism is. This is what the mechanism is. We'll feed all these data into the models and we'll get these results. These are the possible outcomes and applications in the field of biological sciences. And the challenges in multimodal genomics is data integration. As the data we provide is more complex, it is difficult to integrate. And the second one is computational complexity. As I told earlier. Yes, ma'am. This is the conclusion. Multimodals have a promise, have shown a promising future for in the field of biological sciences in the following ways. So, thank you.
Encounter any challenges in integrating data from the multiple models? Have you worked with these multiple models?
Ma'am, I'm learning, ma'am. I'm
Okay, you have not worked yet. You are just learning this topic.
Yes, ma'am.
Okay. So how you say that the accuracy and the data analysis which is from this multimodals are perfect?
Because it actually depends on the data we that we use to train them, ma'am. So when we use a large amount of data to train the models, we'll definitely get accurate models. There are machine learning concepts that improves the accuracy and prediction.
Okay.
We use algorithms to increase the accuracy, ma'am.
Okay, thank you, Shreya. Now, I would like to call upon the next participant, Ms. Inbavalli from Bharatidasan University. Ms. Inbavalli,
Yes, ma'am.
are you
Good morning,
here?
ma'am. Can you hear me?
Good morning. Yes, please share.
Yes, ma'am. Is it visible, ma'am?
Yes.
Good morning, one and all present here. I'm Inbavali. I'm going to present recent advancement in nanotechnology. As we are all aware of that nanotechnology, what do you mean by nanotechnology? It is a branch of technology that deals with the dimension and tolerances of less than 100 nanometer, especially the manipulation of individual atoms and molecules. So what we are going to discuss in this recent advancement in nanotechnology. So the subtitle I have provided, transforming science, medicine and technology. So recent advancement, we are all aware of that so many recent advancement which is present, the particularly in the drug delivery system, medicine, and one more thing is efficient solar cells. That is one of the nanomaterial which is present in the quantum dots, And tissue engineering, there is a method which is called green synthesis using biological sources, particularly in silver and gold nanomaterials. Using these kind of materials, there are n number of researches is going on. Then another one is important one, the ma'am taken has the previous topic, that is nanofibers. Nanofibers which is used for this wound dressing and antibacterial coating. Now, so we are going to discuss about the introduction to nanotechnology. The time limit is less than, so that I am providing the main important point. So nanotechnology, that is definition, we can say that multiplying matter at the atomic, molecular and supermolecular scales for innovative applications. So what are the innovative applications in this nanotechnology? As I said earlier, there is the first important, that's in drug delivery system, medicine, nanomaterials which is present in that medicine, and then energy, electronics and environmental sciences. So what is the significance of this technology? It will be enables the creation of materials and devices with novel and novel procedures than that functionalities. Then next, semiconductors. Semiconductor quantum dots. As I said earlier, that is one of the efficient solar cell, the developing efficient solar cell. One of the thing is quantum dots. It may be known as that semiconductor quantum dots. These are the nanoscale semiconductor materials, typically which is ranges from 1 to 10 nanometer. So because of their size approaches nanoscale, these quantum dots demonstrate discrete energy levels leading to size-dependent optical and electronic characteristics. So that these kind of materials have generated considerable interest in areas. What are the areas? Up to electronics, photonics, biomedicine and environmental sensing. So what is the overview of this advancement in semiconductor quantum dots? That is nanometer-sized semiconductor particles with size tunable electronic properties. Tunable electronic properties here, that means that some kind of electronic activities in our cells. So we are going to find out that one. So some important, we know that one, some important nanotube, that is carbon nanotube, graphene, which is present in that one. Using that techniques only we are using so many, find out that in that medicine properties. And efficiency CQDs for applications like light emitting devices and lasers also. Some applications involved in this quantum dots, biomedical, optoelectronics, catalysis, environmental sensing, and photonics. Biomedical, we know that one, subcellular imaging, biosensors, and drug delivery. Optoelectronics, high efficiency light emitting diodes and solar cells. So catalysis also, which is application, photocatalysis for energy and environmental applications. So what is the key feature of this advancement? That is tunable photoluminescence properties. Next, there is a conclusion about this advancement and semiconductor quantum dots. That will improve their functionality and broaden their range of application from energy efficient lighting and photovoltaics to cutting edge biomedical applications. So this is the first recent advancement in the nanotechnology, advancement in semiconductor quantum dots. Then second one is MXN nanomaterials in, it's not visible, two-dimensional technology, nanomaterials, which is composed of transition metal, carbides, nitrates, and carbonitrates. So this kind of technology, which is how discovered in 2011 onwards, and using their exceptional electrical conductivity, mechanical flexibility, high surface area, and easy of surface modification. So particularly in this kind of technology, which is suitable for use in application, wearable technology. We know that when wearable technology nowadays, there is a smartwatches and something cloth typing. So many things are nowadays improving, so that they are using this kind of nanomaterials, MXN nanomaterials. What is the innovation of this materials, this wearable technology? Particularly in that based on the textiles and then wireless energy transfer in wearable devices. So advantages, flexibility and resilience under mechanical stress, conductivity suitable for energy grids in clothing. So impact of this kind of technology, new avenues for wearable technology with integrated power solution. The next is third, room temperature quantum computing. So we are talking about recent advancement. This is one of the recent advancement in nanotechnology. Room temperature quantum computing is a highly sought after goal in the field of quantum computing, and then traditional quantum computers, such as based on the superconducting qubits or trapped ions, typically require extremely low temperatures to maintain the quantum coherence. Breakthrough of this room temperature quantum computing, use of the van der Waals heterostructures for terahertz frequency control. So application of this quantum computing without the need for cryogenic cooling and potential significant reduction in operational cost and increased accessibility of quantum devices. So that this is a successful realization of room temperature quantum computing could democratize access to quantum technologies, reduce infrastructure cost, and accelerate the development of application across the wide range of industries they are using. That the reason, one more reason advancement in nanotechnology is light-powered nano antennas. These are miniature devices that can absorb and interact with light at the nanoscale. So these nano antennas are designed to function similarly to traditional antennas, but operate at much smaller scales, typically in the range of nanometers. So the term light powered, that is refers to the ability of these nano antennas to harness
Ms.
energy.
Inba, your time is up. Please fast.
That's it, ma'am. That's it. So this technology, nano-sized cold structure coupled with graphene to capture and focus light. So that is what, as I said earlier, that is a carbon graphene structure. So this kind of the things which is going to be utilized to nano-sized cold structure. So nowadays the recent advanced research is going on this many green synthesis gold particles to find out the biological sources. Applications, ultra-fast microelectronics, photodetectors, and night vision. So mechanism of this kind of thing, optical hotspot, create pathways for electron flow. So the one more is advancement in 2D nanomaterials, understanding motion in 2D nanomaterials like hexagonal boron nitride. That is what the discovery.
Ms. Inba, we should call the other participants. Kindly fasten.
Yes, ma'am. Enables flexible electronics and high strength composites, which is used for this one. Then one more is future directions in nanotechnology. So there is a emerging trends and challenging. Emerging trends, nanomedicine, sustainable energy, environmental applications, and challenges, safety and toxicity concerns, scaling up for commercial applications. For this summary of this or conclusion of this paper, nanotechnology holds transformative potential across various sectors, offering solutions for global challenges in medicine, energy, environment, and beyond. So in future developments will continue to reshape industries and improve quality of life in profound way. Thank you, ma'am. Thank you so much.
Thank you. I request all the participants to kindly stick to the timings because there are a lot of participants. So just 4 minutes time is there, but each one are presenting for a long time. Kindly stick to the timings. And Ms. Inba, I have a question for you. What are the key challenges in scaling up nanotechnology applications in the laboratory? Like if suppose you're finding some clinical settings or you're addressing any challenges of researchers, then how will you scale up the nanotechnology applications there? Can you hear me, Inba? Miss Inba, can you hear me?
Ma'am, can you hear me?
Yeah.
Ma'am, what is your question?
My question is if you're having some challenges in scaling up the nano applications in lab, like in a research lab, how will you address the researchers? Like a researcher who is working in this nanotechnology, if he is having some challenges, how can you give your inputs to them?
Ma'am, one of the important challenges cost effectiveness.
Okay.
And then toxicity and environmental concerns, and we can say synthesis complexity, and then characterization and quality control of this nanomaterials.
Okay, can you use the artificial intelligence in learning about the nanomaterials
Yes, ma'am, we can use.
in case of designing the application of nanomaterials like drug designing or anything?
Yes, ma'am, we can go for that one. So
Yes.
many.
Okay. Okay, thank you, Ms. Inba.
Yes,
Now,
ma'am.
I would like to call the next participant,
Thank you, ma'am. Thank you so much.
Dr. B. Sendil Kumar from Vinayaka Mission. Dr. B. Sendil Kumar. Sir, are you here? Yes, sir. Can you present? Sir, kindly test your audio. We can't hear you. Dr. Sendil Kumar, your slide is visible, but we can't hear your voice, sir. Sir, can you unmute your audio?
Ma'am, can you move with next participant, ma'am?
Yes, sir. I'll move, sir. I think he have some issues, sir. Dr. John C. Carolyn from Nirmala College of Women, Coimbatore. Dr. J. John C. Carolyn. Ma'am, please check your voice, ma'am. We can't hear you as well.
Can you hear me, ma'am?
Yes, ma'am. Please start. Ma'am, start from your title slide.
Yeah, yes, ma'am. 1 second. My presentation on the topic is streamlined synthesis and characterization of nanoparticles using degradable waste material. The sustainable development and its research areas. Coming to the sustainable development, we have lots of sustainable development, mainly in the areas of crustacean cell, crab waste, shrimp waste, and molecular molasses. And these, I have taken a topic based on the crustacean waste, that is a crab waste, which we have a lot in the coastal areas. It can be used as a drug in many of the drug applications. And coming to the synthesis, how I have taken the synthesis from the chitosan from crab shell. These are the different synthesization methods, that is demineralization, deprotonation, and deacetylation. And importance and benefits of curcumin, which I have added and loaded in as a bioactive material into the chitosan. This is the preparation of chitosan, where TTP is loaded with curcumin, and we obtained a nanoparticle. Where we have taken chitosan, we added TTP, and the chitosan TTP nanoparticles is again loaded with curcumin, and we get a chitosan TTP loaded bioactive material. And after getting the material, we have characterization techniques like the SEM, TEM, IR, UV, antimicrobial studies, and XRT. And I have done also the computational methods like retrieval of proteins, ligands, SWID, ADME method, and toxicity prediction and molecular docking and drug likeliness and bioactive score. Coming to the characterization techniques, we have TEM. In this, the curcumin and the loaded chitosan material have hollow spherical nanoparticles, which is a dark solid spherical particles, indicating that entrapped of curcumin inside the hollow spherical capsule. And the next picture is the SEM. Here we have got a smooth surface of the spherical morphology. And coming to the IR, we have got peaks for TTP chitosan nanoparticles, that is 1658 centimeter inverse for the amide binding, and TTP from 1928 to 1759 centimeter inverse for phosphate groups, and the other groups have been indicated. And UV we have got for 424 nanometer peak, and in XRD we have got the nanoparticle indication of 9 nanometer. The antibacterial efficacy of chitosan nanomaterial is also studied, wherein we have got we have done both for positive and negative bacteria. We have got a good zone of inhibition in both of it. And coming to the computational simulation of bio-waste material, I have done for 3D chemical structure of chitosan and curcumin. And this is the bioactivity radar, produces a graphical representation of drug likeliness, that is bioavailable drug, that is liposity and size can be seen in this bioactivity of the compound. It can be also determined by using computational simulation. And this is the hydropathy plot of the chitosan as well as the curcumin, wherein the hydropathy, based on the hydropathy plot, the bio-waste material can be enhanced by using computational method. This is the target, that is Swiss target predictions for both chitosan and also the curcumin, where we can use smaller target molecular proteins. And this is for the curcumin. And this is the gestational absorption and blood-brain barrier penetration using boiled egg method, wherein our drug can be used, whether it can be used effectively or not. And next one is the docked conformation showing the curcumin encapsulated chitosan in JAK2 protein. And this is the docking conformation representation, where a curcumin and the protein is embedded, or it is showing the interactions well. In conclusion, I could conclude that this curcumin loaded, that is chitosan TTP curcumin loaded bioactive material, which is taken from the waste material of as chitosan, it can be used as a very good used in very it can be used as pharmacological activity areas, and also it can be used as an effective drug. And we can do more target predictions, bioactivity radar with in the forthcoming future, and can be used as used in it supports the breast cancer growth inhibition, and will control the growth, and it can be studied in near future.
Thank you, Dr. Johnson. That was a nice presentation.
Yes.
Can you tell us, like, how did you optimize the synthesis process of
Optimization.
conversion of these crustacean shells into nanoparticles?
Yes, ma'am. Optimization, I have done all the deacetylation, deprotonation, and the methods I have shown here, ma'am. This one, ma'am.
Okay.
And I have
So
taken that.
Okay. Did you find
Yes,
any
madam.
challenge in this, or
Yeah, the challenges while taking the crab shell, it is very easy, but without the agglomeration, that is when the curcumin is loaded to a TTP and chitosan molecule, I faced many challenges like agglomeration, and the particle size were different when in temperature when the temperature varies, the particle sizes also vary. So I have gone through that, ma'am.
Okay. And you also showed about the gastrointestinal relationship between
Yes, ma'am.
a
Egg.
test with the
Yes, ma'am.
boiled egg.
Egg, ma'am.
So how
Yeah,
did
yeah.
you do that?
I did that in during the
Can you show me
computational
that slide,
method
ma'am?
studies, madam.
Yes, yes. The boiled egg method. Yes.
Yes, yes, boiled egg method with the computational studies, madam.
Okay. So it is by computational method only, not by the laboratory method.
Laboratory method, I have shown like SEM, TEM, XRD, those methods, madam. I also wanted to know how effective it is in computational methods. So I opted for all the computational methods also, madam.
Okay, okay.
So these are the methods I have done in the laboratory and find that it is a nanoparticle. Besides that, I wanted to do with that computational methods how it is effective as a drug. So I have compared both of it and it showed a good active compound, ma'am.
Okay, ma'am. That's nice. Thank you, ma'am.
Thank you. Thank you so much, ma'am.
Can I call the next participant, Dr. R. Nithya Dharani from Srimati Indira
Yeah,
Gandhi
ma'am.
College, Trichy?
Yeah, ma'am. I'll share my screen, ma'am.
Yes, ma'am. Yes, ma'am.
Ma'am, is my screen visible, ma'am?
Yes, ma'am. Yes, ma'am.
Yes, ma'am. Very good afternoon, ma'am, and all. So my topic is. I'm sorry for the trouble. Yeah, ma'am. So my topic of presentation is bioengineering of fruit paste into SCP to bolster the COVID-19 recovery. So I would like to state that I'm in a study supported by the National Institute of Allergy and Infectious Diseases. Severe COVID-19 cases were shown to cause long-lasting changes, especially in the immune system. And in more worst or severe cases, it is said that it can turn off the genes in certain stem cells too. So to overcome this, the current study has been conducted. So it is critical to restore the immunity post-COVID infection, and COVID infection, it hugely damages your body and immunity with a lot of stress, slowing down the metabolism processes, immunological and reproductive functions. So with the increase in the population, protein deficiency is the most common cause of impaired immune function. So this can be recovered or addressed only if one is able to restore the immunity and the overall health. So protein, anyhow, it plays an important role and can be a powerful differentiator in reactions. So as a result, SCP, it forms a high protein food that you should, you can have after COVID-19. So the term single cell protein was coined by Carl L. Wilson, and it is commonly used as a food supplement, especially for humans, wherein it has been used as a high energy rich food, and as well as it has been given to the animals as a feed. So it is also called as a biomass, bioprotein, or microbial protein, which is needed to restore the immunity, especially with people with post COVID-19 symptoms. For the reasons that it contains numerous fat, carbohydrates, nucleic acid, vitamins, minerals, and it is rich in certain essential amino acids like lysine and methionine. I would like to state that India is the second major producer of fruits and vegetables in the world. And according to India Agricultural Research Data Book, the total waste generated from fruits and vegetables alone, it accounts to 50 million tons per annum. So we all know that the conventional substrate, it includes starch and molasses, and carbohydrate substrate. Using this, it is most widely used for SCP production due to the fact that carbohydrate are natural microbial substrates. So in this work, fruit peels of Mozambique, pomegranate, and cucumber were introduced as a potential substrate for the fermentation to produce the bioprotein. So the objective of the study, it is the collection of fruit peels, waste, and preparation of the fruit extracts, and isolation of Saccharomyces cerevisiae to estimate the protein, carbohydrate, fat, ash content of the ash contents, fermentation and harvesting of single cell protein, and finally the bioconversion part of it. So sample collection was done. Mozambique pomegranate and cucumber peels were collected from the local markets of Trichy, Tamil Nadu. The fruits were generally washed with running water to remove any dust particles, and peels were oven dried at 40 to 50 degrees centigrade. So coming to the methodology, isolation of Saccharomyces cerevisiae. So the yeast colonies were grown in YPT agar, which is a selective media. And next is the identification of Saccharomyces cerevisiae. So strains were identified on the basis of morphological characters, which includes the lactophenol cotton blue staining and gram staining. Then preparation of fruit hydrolase. So the fruit powders were degraded to convert the cellulose into simple sugars by chemically treating them with 50 ml of 10% hydrochloric acid. So these filtrates were collected and the fruit hydrolase were used as a substrate. So next is a biochemical analysis of the fruit waste. So estimation of protein by Laurie's method, estimation of carbohydrate by Anthron, fat by Zach, and ash by AOAZ method were followed. And coming to the fermentation process, so submerged fermentation process were carried out in Erlenmeyer flask. So in 100 ml of the extract, 3 grams of glucose and lactose were added as carbon source. And to this, 0.2 gram of sodium nitrate and ammonium sulfate were also added as nitrogen sources. So the pH was adjusted and it was kept at 28 degrees centigrade for almost 7 days after inoculation period. So the bioconversion part of it. So after 7 days of biomass was separated from the culture broth using the Wattsman filter paper, and the amount of protein estimated by the method of Laurie's using BSA standard. And similarly, the carbohydrate was estimated and the crude fat were also estimated, and the ash content. So coming to the results and discussion, the results clearly indicated that the higher percentage of protein was found in the yeast biomass when Saccharomyces cerevisiae was grown on glucose and lactose. So this indicates that the biomass yield can be increased when a carbon source like glucose and lactose is added to the medium. So as the organism grows, it produces more amount of cellulases, and these enzymes it mass available ma'am, more amount of glucose monomers, especially from. Ma'am, can I continue?
Yes, please continue, ma'am.
Yes, ma'am. Yes, ma'am. So as the organism grows, it produces more amount of cellulases, and these kind of enzymes it make available more of glucose monomers for the Mozambique, pomegranate, and cucumber in the medium, as well as it helps in the release of the nitrogen for the growth. Okay, so this is the chart showing that is the estimated amount of protein, carbohydrate, fat, and ash before fermentation. And this is the chart showing after fermentation process, where you could see the increase after using the glucose and lactose as a substrate. So this study, it shows that higher yield of single cell protein, it can be obtained from Saccharomyces cerevisiae. Addition of glucose and lactose, it provided the available carbon source for the organism, and hence it increases the rate of single cell protein production. So the current study shows that Mozambique, pomegranate, and cucumber extract is a proper substrate for the single cell production, and good nutritious food can be supplied with the least expenditure of cost, thereby converting this food waste into protein-rich food. So the study, it reveals that Mozambique, pomegranate, and cucumber waste with good nutrient, it can be converted into a proteinaceous food as well as for feed for the animals. Utilizing them will bring an end to the protein deficiency around the world. So I would like to conclude that this bioenergy of, bioengineering of this food waste into SCP, it cuts down various factors like protein deficiency, environmental issues, by the way that the low cost organic materials is being converted into valuable product. They are effective in cost cutting, especially like SCP is a relatively cheap protein, and year round production is there. It takes up less space and time as well, and ultimately it yields a higher protein content. Thank you, ma'am.
Thank you, ma'am. It was a very nice presentation, and you were very fast also. Thank you for that, especially.
Due to time constraint, ma'am.
Yeah. So, and it's like you spoke about the bioengineering strategies.
Yes, ma'am.
Like what will be what bioengineering strategies are employed to enhance the protein content in it?
Yes, ma'am. This work actually I have started with conversion of, I mean, it is exactly the bio conversion part of it. So this SCP has picked up the speed and dynamics, especially it has its advancement in metabolic engineering and CRISPR-Cas also, ma'am. It emphasizes the second generation substrates and fermentation for a circular economy, ma'am.
Okay.
Yes, ma'am.
Ma'am, can you also tell me, like, are there any specific bioactive compounds in SCP derived food waste?
Yes, ma'am. It has, of course.
It has,
The,
like,
the main,
I mean, the specific bioactive compounds, which especially shows some therapeutic effects for post-COVID symptoms. Can you name some of the bioactive compounds?
ma'am, it is in the process actually. I have to
Okay.
go for chromatographic techniques as well, ma'am.
Okay.
Yes,
Okay.
ma'am.
So much. Thank you.
The main work is actually it promises to solve the global nutrition problem, ma'am. For the reason the
Okay.
work was taken, is ma'am.
Okay. Thank you, ma'am. Thank you so much.
Thank you so much, ma'am. Thank you.
The next participant, Dr. P. Divya from Nirmala College of Women.
Yeah.
Dr.
Good
P.
afternoon, ma'am.
Yes, ma'am. Yes, ma'am.
Yeah, good afternoon, ma'am.
Good afternoon.
Ma'am, is my screen visible, ma'am?
Um, Not yet, ma'am.
Yeah, one. Now, ma'am?
Not yet, ma'am.
Yeah. I hope
Yes.
it's now. Yeah,
Yes.
yes,
Yes.
ma'am.
Yes.
Yeah. I'm Dr. Divya, Assistant Professor from the Department of Chemistry, and I'm here to discuss my work on the nanoparticles, the precursors for effective synthesis of organic compounds. So, at an outset, I would like to. I'm ignoring all the introductory part. And the objective of my work is to synthesize copper nanoparticles from the fish scales of Sardinella longiceps and to characterize the nanoparticles and to test it for the synthesis of dihydropyrimidone and thiones, thereby studying the effect of catalyst concentration on the substrate selectivity and the effect of variation of microwave power. Initially, the fish scales of Sardinella longiceps were collected from the local fish market and they were washed with distilled water and thoroughly they were finely powdered after washing, after drying, and they were and it was boiled in 450 ml of distilled water and heated at 80 degrees centigrade for 30 minutes, after which it was centrifuged and the copper nanoparticles were prepared by using copper sulfate pentahydrate, wherein 2 grams of copper sulfate pentahydrate was treated with 4 ml of double distilled water and 10 percentage of fish scale extracts were added to it. It was reflexed for 100 degrees Celsius for 1 hour till the color changed to dark brown, which indicated the formation of nanoparticles. So, having synthesized the nanoparticles, the next part of the work was to employ the synthesized copper nanoparticles to study to catalyze the Bignelli reaction. Bignelli reaction is basically the reaction between aldehyde, urea or a thiourea, and when it is actually uh, treated with an active methylene group. This is actually the synthetic, schematic representation, wherein the reactants were treated with copper nanoparticles. So this is the schematic representation one, wherein the aromatic aldehyde, ethyl acetate, and urea or thiourea was stirred in a suspension of copper nanoparticles in ethanol under microwave irradiation. The completion of the reaction was monitored by TLC. after monitoring the completion, which resulted in the precipitation of the product. The precipitate, being in a solid form, was filtered, dried, washed with petroleum ether to remove the residual particles, and then was recrystallized from ethanol to afford the crude particle. The catalyst could be recovered after the evaporation of the aqueous layer and can be used for subsequent reaction without losing any significant activity. The products were identified by the physical data. Having earlier reported this in our laboratory with nickel nanoparticles, it merely coincided with the already observed melting point. So these are the products and the observed melting point, which was in very close relation, close correlation with the already reported melting points. So having synthesized and having relating it to the already reported melting point, the effect of the catalyst concentration was studied. So the catalyst concentration was varied from 2% to 10%, and we found that there was gradual increase in the yield after a concentration of 8 mole percentage. There was a steady or there was a constant percentage yield. So we fixed the catalyst concentration to be 8%. So next is the effect of variation of the microwave power. So similarly, the power in watts, microwave watts, was increased from 120 watts to 360 watts, and thereby we could clearly see from the table that as the time, as the power increased, the reaction time in minutes were decreased, and thereby increase in the yield was actually noted. So with this, we concluded that the optimum optimum power of 360 watts gave a maximum yield of 80%, with the catalyst concentration being fixed at 8 mole percentage. So coming to the conclusion, having used the copper nanoparticles, I conclude that it is an economic, quick, safer, and it is a one-pot synthesis of the famous Brignelli reaction. And it has also got some environmental advantages, like the reaction is clean, it has got a low loading of the catalyst, shorter reaction time, and the substrate can actually be varied. And this method will actually promote the researchers to go in for the eco-friendly solvents instead of toxic solvents as a reaction medium. Thank you so much, ma'am.
Particle active catalyst in
Yeah,
the synthesis of
ma'am,
organic compounds.
ma'am,
Can
can
you
you
hear
please
me?
repeat the question?
Yes,
Yeah,
yes.
yes, ma'am. Please tell me, ma'am.
Your work is on the nanoparticles which are
Acting
acting
as a
as a
catalyst.
precursor for the effective synthesized organic components,
Yes,
right?
yes,
So,
ma'am.
what are the factors that influence their efficiency in these reactions and how they are acting as a catalyst? Can you say it in few words?
Yeah, yes, ma'am. Like
The
they are
factors
actually
affecting the
acting as
reactions.
factors affecting is like the temperature and of the nanoparticles. Is it not, ma'am?
Yeah,
The
the
catalyst
factors affecting the
concentration.
influence of the nanoparticles.
Yeah, in traditional methods we do use heating of the reactants and or by stirring you can do, ma'am. But here the catalyst is acting as an adsorbent, and the reaction is favored by the process of adsorption, and the factors affecting are the time, the percentage of the catalyst that is being moderated, ma'am.
Okay, so when the synthesis is by nanoparticles, how do you compare and justify that the traditional synthesis is better than, I mean, it is better, or your synthesis is better? How will you
I
justify
have
your?
actually presented I've actually presented a part of my work, and my
Okay,
earlier works I've actually compared it with a nickel nanoparticle, ma'am. So
okay,
from that,
okay,
I could, by using various nanoparticles, I've actually tried, and then there
okay.
I could see a comparatively higher yield of the products in case of
Okay.
nanoparticles, ma'am.
Okay, ma'am. Thank you.
Yeah,
And
thank you so
Dr.
much,
Mary
ma'am.
Fabiola is a part of this work, or she'll
Yeah,
present
yes.
again, ma'am?
No, ma'am. This is the part of the work, ma'am.
Okay, okay. Okay. Thank
Yeah,
you, both of
okay,
you,
ma'am. Yeah,
Dr. Divya and
thank you,
Dr.
ma'am.
Mary Fabiola. Thank you.
Thank
And
you so much,
now
ma'am.
I would like to call the next presenter, Ms. Bhavdarini from Dr. Mahalingam College of Engineering and Technology.
Yes,
Ms.
ma'am.
Bhavdarini? Yes.
Yes, ma'am. Good afternoon, ma'am.
Good afternoon. Please share your screen. Yes, it is visible. You can start.
Okay. Good afternoon, everyone. My name is V.Y. Bavadarni, and today I will be presenting on advances in organ and tissue engineering. This field is revolutionizing how we address the organ failure and transplant shortages. Let's dive in. Organ failure remains one of the leading causes of death worldwide. Traditional organ transplantation faces challenges like donor shortages, immune rejection, and high cost. Organ and tissue engineering aims to overcome these limitations by creating bioartificial organs. Today, we'll explore how these technologies are progressing and their potential impact on healthcare. And organ manufacturing involves creating bioartificial organs using living cells, biomaterials, and advanced technologies to replicate the natural organs. The purpose is to um, address organ shortages, reduce transplant dependency, and provide permanent solutions for organ failure. These organs are customized for individual patients and offer the promise of lasting healthcare benefits. And several groundbreaking technologies are driving the field of organ manufacturing. First, 3D bioprinting uses a multi-nozzle techniques to precisely place cells and biomaterials to create the organ structures. And next, decellularized matrix technology involves removing the cells from donor tissue while preserving the extracellular matrix, which can be reseeded with patient-specific cells. A magnetic and electrophotic cell manipulation are used to guide cells into the specific patterns, improving the tissue structure. Finally, stem cell integration allows for the regeneration of organs by differentiating stem cells into the specialized cell types. And types of artificial organs. And artificial organs are classified into three types. Mechanical organs are made from the synthetic materials like plastics or metals and are often used as a temporary solution, such as heart valves. And biomechanical organs combine living cells with the mechanical components, creating the hybrid solutions like prosthetics. The most promising type is bioartificial organs, which are fully made from the living cells and biodegradable materials, offering the potential for permanent restoration of organ functions. Milestones in organ engineering. The field has made tremendous progress over the years. In 2004, the first single nozzle 3D bioprinter was developed. By 2007, a dual nozzle technology allowed the printing of multi-cell structures. In 2010s, advancement in multi-nozzle printing led to the creation of complex organs like liver. Today, the functional organ prototypes are being used in research, moving closer to the clinical trials. Organ and tissue engineering has broad applications. Vascularized tissue like skin grafts and blood cells are being engineered to aid healing. And organ prototypes, including the liver and kidneys, are being developed for both the transplantation and medical testing. In cancer research, by creating the tumor models for drug testing. And bone and cartilage engineering is advancing treatments for orthopedic conditions. And lastly, the regenerative medicine uses the tissue engineering to regenerate damaged tissues, potentially offering new treatments for various diseases. And challenges in bioartificial organ engineering. Despite the exciting progress, there are several challenges. Technically, creating an organ that perfectly replicates the natural function is complex, especially with intricate networks like blood vessels and nerves. Biologically, ensuring that tissues integrate and function properly once implanted is difficult, and immune rejection remains a concern. There is also an ethical and regulatory issues surrounding the use of the stem cells and genetic modification. Finally, scalability is a challenge. Producing organs in large quantities for widespread use is still a work in progress. And future directions in organ engineering. Looking ahead, the future of organ manufacturing is bright. Artificial intelligence play a role in predicting organ functions, optimizing designs, and improving bioprinting techniques. And in patient-specific organs become reality, which could significantly reduce the risk of rejection. Nanotechnology will enhance cell integration and nutrient delivery to clinical applications with interdisciplinary research, pushing the boundaries of what possible in organ engineering. And benefits of bioartificial organs. They improve the health outcomes by reducing the wait time for transplants and providing long-term solutions. And economically, bioartificial organs could lower healthcare costs by replacing the need for long-term treatments like dialysis. In conclusion, organ and tissue engineering holds the potential to transform healthcare by addressing organ shortages, reducing the transplant dependency, and offering long-term solutions to organ failure. While the challenges remains, the progress in this field is promising as technology continues to evolve. We may soon see the bioartificial organ become a standard part of medical practice, improving the quality of life for millions. Thank you for your attention. I'd be happy to take any questions now.
Thank you, Ms. Bhavdarni. And I would like to ask, what are the recent breakthroughs in scaffold designing and biomaterial development, which are playing an important role in engineered organs and tissues? Any recent breakthroughs in scaffold design?
Yes, ma'am. Ma'am, scaffold design is a critical aspect of bioartificial organ manufacturing, ma'am. Intricate the architecture of natural organs, including vascular networks for blood flow and neural pathways and hierarchical structures. And also cell integration, multiple cell types are arranged in pre-designed architectures to mimic the natural organ functions.
Okay, thank you, Bhavdarni. Yes. And the next participant is Ms. Aisha Sabeen from Maradha Kesari Jain College. Ms. Aisha.
Good afternoon, ma'am. Good afternoon, ma'am. Can I share my screen, ma'am?
Yes, ma'am. Yes, ma'am. Please.
Is it visible, ma'am?
Yes, ma'am. It is visible.
Can I proceed?
Sure, ma'am. Please proceed.
Yes, ma'am. Yes, ma'am. Thank you, ma'am. Good afternoon, dignitaries. Myself, Aisha Sabeen, Research Scholar, PG and Research Department of Biochemistry from Maradha Kesari Jain College for Women, Vanembadi. The title of my study is Green Synthesis of Calcium Oxide Nanoparticles using the herb Anethum graveolens. As we all know, herbal plants have long been utilized for many health benefits as well as alleviation of various diseases. But side effects from herbs. Yes, ma'am.
Ma'am, kindly keep the slide in presentation mode, ma'am. Then viewers will be benefited, ma'am. Thank you.
Yeah, ma'am. Am I clear, ma'am? Now is it clear? Yeah. I have put it in slide share, ma'am.
Okay, please proceed, ma'am.
Yeah, ma'am. Yes, thank you. However, side effects from herbs do exist, and my work is focused on oral health care. As we all know, oral health care is an essential part of a person's overall health and well-being, and herbs have long been used to found to possess potential benefit effects in dentistry. Basic herbs which we see in our day-to-day lives are neem and miswak, and the increasing demand for the herbal plants has renewed interest in pharmaceutical industry in the production of herbal healthcare formulations, herbal-based cosmetic products, and as well as herbal nutritional formulations. The objectives, actually this is a part of my study. The aim and objectives of the study is use of plant extracts in the green synthesis of metal nanoparticles, and testing the antimicrobial activity of the synthesized herbal formulation. With regard to the materials and methods, the herb which I have selected for my study is dill leaves. The scientific name is Anithum gravulans, which is in Tamil we call it as sombu kirai. And along with that, as my plan is to prepare the calcium oxide nanoparticles, we have used the metal salt solution calcium hydroxide, which will be tested for its antimicrobial activity. And the herbal plants were chosen based on their anti-carcinogenic and anti-inflammatory properties. We have chosen two herbs. One of the herb is the dill leaves, which is nothing but Anithum gravulans. This is a smaller herb which we formerly use for as a herb or a spice for flavoring our food. And this is the synthesis of calcium oxide nanoparticles using dill leaves. We have synthesized the calcium oxide nanoparticles. Once we had done with the synthesis, and we have gone for the antimicrobial activity against carcinogenic microbes like Lactobacillus species, Streptococcus mutans, Streptococcus aureus, and Candida albicans. We have gone for the anti-inflammatory activity using BSA assay.
Slide.
Yes, ma'am.
Your slide is not moving. It is just stuck
Slide.
in introduction slide.
Now, ma'am.
Yes, ma'am.
Yeah. Sorry for the inconvenience. This is with synthesis part, and we tested the synthesized nanoparticles for its antimicrobial activity against oral pathogens like Lactobacillus species, Streptococcus mutans, Streptococcus aureus, and Candida albicans. And we also carried out anti-inflammatory activity with BSA and EA. Our further study will be dealing with cytotoxic effect of the synthesized nanoparticles, followed by characterization, and we'll be dealing with the anti-carcinogenic properties of synthesized nanoparticles and the toxicological evaluation using zebrafish model. I would like to conclude my presentation by saying that even though the advancement of nanoparticles are the same that make them dangerous, like the small size, surface properties, migration, aggregation, but research into nanoparticles is one of the most studied branch of science owing to its unlimited fields of applications. Thank you.
Thank you, ma'am. That was a very nice presentation.
Yes,
And,
ma'am.
Can I ask you something? Like,
Yes,
how
ma'am.
does
Yes, ma'am.
yes, you have selected the plant, Anithum plant, that is the
Yes,
Som
ma'am.
Kires.
Yes,
So, what
ma'am.
are the specific roles of this dill leaves?
Ma'am, dill
Compared
leaves.
to the traditionally, you have some other
Yeah,
traditional herbs
ma'am.
also.
Yeah,
Why you
traditional.
selected?
Yes, ma'am. Basically, if we see, ma'am, like even in any toothpaste ad, basically we get to see the neem miswak, and so many works have been carried out in the field of like herbal medicine or medicinal therapeutics using neem and miswak. Actually, first what we did was we listed out so many herbs having oral healthcare properties, basic oral healthcare properties. We selected, along with the dill, I have also selected the dandelions, that is Draxum officinale, that is got Seemai Kattu Mullangi in Tamil. These are the
Okay.
two herbs which I have selected for my study, and very minor work have been carried out using these plants, and these plants proved they have been used in as a spice in our day-to-day life, spicing our food. That is what do we say in that culinary. They have culinary aspects both, and they are also been used as tea formulations. Dandelions and dill have also been used in that way. So we thought we'll go with this as they have culinary properties.
Thank you so much.
Ma'am. Thank you, ma'am.
All the best for your work.
Thank you, ma'am. Thank you so much.
Yes, thank you. The next participant, your name is not have been registered, but your college name is PSG College of Nursing, Coimbatore. On the topic effectiveness of coping strategies regarding fear of missing out academic performance among students. Is the candidate available? A candidate from PSG College of Nursing. Okay, if not available, I'll go with the other participant. Ms. Sulochana from DKM College of Women.
Yes, ma'am. I'm here, ma'am.
Yes, can you present?
Yeah, ma'am. Sure, ma'am.
Ms. Sulochana, you have any problem in sharing the screen?
Ma'am, can you see the screen
No, not yet.
now?
No, I can't see your screen. If you have any problem, can I call the next participant?
Okay, ma'am.
Mr. Raman, are you ready? Mr. Raman?
Yes, ma'am.
Yes. Can you try
Yes,
now?
ma'am. Am I audible, ma'am?
Yes, you're audible.
Yes, ma'am. I can try now, ma'am.
Yes, please try.
Okay, sure, ma'am. I'm sharing my screen.
No. Please share your presentation. Your mobile is visible. The next participant, Shakti. Shakti, are you ready?
Yes, ma'am. I am Shakti.
Can you try now?
Yes, ma'am. Ma'am, can we move on next participant, ma'am?
Yes, sir. Yes, sir. I'll call next participant.
Ma'am, can I try, ma'am?
Yes, please try.
Okay, ma'am.
Please try, Ms. Sulochana.
Ma'am, can you see my screen, ma'am?
No. Miss Arshia Begum, are you ready? Miss Arshia Begum?
Yes, ma'am.
Can you try now? Yes, your screen is visible. Please start.
Good afternoon, ma'am and sir, all my dear friends. My topic is about copper nanoparticles. So this is my content which I present today. So introductions about my topic is nanotechnology is a promising field which develops the novel materials with a unique properties. The nanotechnology are used copper nanoparticles. It has a significant addition with their excellent like electrical, thermal and antimicrobial properties. In this lotus seed, in a copper nanoparticle, I used a lotus seed, which is a scientific name is Nilumba nucifera, and it is also known as a makhane. This is the rich in bioactive compounds like flavonoids, alkaloids, and saponins. Also, these seeds making them ideal to reducing and stabilizing the agents of a nanoparticle synthesis. So combining these lotus seed and the nitrate nanoparticles, it shows a greener synthesis route. Also, it produces the copper nanoparticle with desirable properties. The use of a plant extract in this synthesis is to groundbreaking approach, which eliminates the need for reducing agents that is a hazardous. In this lotus seed also has a rich phytochemical composition, which is shown in the green synthesis. Then copper nanoparticle has synthesized from the copper nitrate precursor, which has a special interest with the multifaceted applications. So in this review, I examined the mechanism of a green synthesis of a copper nitrate nanoparticle using a lotus seed extract. Also explored the phytochemical interactions and the characterization of a nanoparticles. Also discussed the broad spectrum activities. This is a seed which I used for my project. The mechanism of a synthesis. In the mechanism of a synthesis, the copper nitrate nanoparticle using a lotus seed extract involves the multiple steps which is interconnected the active compounds in this extract. Also in this mechanism, it includes some steps that is a reductions, nucleations, growth, stabilizations, and the capping of a nanoparticles. In the mechanism of a synthesis, the phytochemical component in the lotus seeds and their role in the nanoparticle synthesis. Here is the role of synthesis and stabilizing function of a phytochemical. First is alkaloids, which is a reducing agents for a copper ions and to stabilize the nanoparticles. Flavonoids to enhance the reducing kinetics and to capping and to stabilize the capping agents. Phenolic compounds, it acts as a both reducing and stabilizing agents. Also, it prevents the agglomerations. Saponins, it to facilitate the nanoparticle dispersion, it increases the solubility. In the mechanism of synthesis, here's some steps which I used, that is a preparation of a precursor and extract, that is a lotus seed extract, reduction of a copper ions, nucleations, growth of a nanoparticle, stabilizations, capping, and surface of a functionalizations. So here's some key factors which affect the mechanisms. First is a concentration of a extract, reaction temperature, pH level, and reaction time. The mechanism of a synthesis, it affects the demonstrate the how nature derived from these components. Also, it can effectively reduce the nanoparticle and to stabilize. Characterization of a nanoparticle. First is a UV visible spectroscopy, then scanning electron microscope, FTIR, X-ray diffractions.
Here, kindly move the slides faster. You are restricted to timings.
Okay, ma'am. Then application of a lotus seed, that is first one is a biomedical application, environmental application, agricultural application, industrial, cosmetic, food industry, renewable energy applications, material science, biomedical diagnostics. The challenges of the green synthesis to how the challenges is facing at time during the process of this. First is a standardization of a procedure, control over nanoparticle properties, scalability, limited understanding of a mechanism, stability and shelf life, limited applicability, environmental and ethical concern, analytical challenges, regulatory and quality assurance, competing synthetic method. So here's the conclusion of this nanoparticle is the using of both copper nitrate nanoparticle and the lotus seed extract. It represents the sustainable approach to the nanotechnology. Also, it has the bioreductive properties in the lotus seed compound, which is not only simplify the synthesis, also it impact the biocompatibility of the nanoparticles. So in this conclusion, I integrate the green synthesis of a nanoparticle, which is not only reduce the environmental impact, also enhance the functions of a resulting materials. In this nanoparticle, I approach the serve as a model for further explorations in the plant-based nanoparticle synthesis and the transformative of a various scientific disciplines. Thank you, ma'am and sir.
Thank you, Arshia. I'll ask you a question like how do the copper nanoparticles synthesized using lotus seeds can be compared with other plant extracts? Why you selected lotus seed extract instead of other plants? How best is lotus seeds?
Nowadays, lotus seed has the more effective, more important to us, ma'am, for heart disease and many more to cure this, to control the disease in our body, ma'am.
Okay, thank you, Arshia. So I would like to call the other participant who is available, Dr. Vinayaka from Sri Venkatramana Swami College. Dr.
Ma'am,
Vinayaka.
Dr. Shaktivel, ma'am, who is ready.
Yes, Mr. Shaktivel.
Yes, ma'am.
Can you?
Oh, yes, ma'am. I will share with you
Yeah,
my slide.
at least now you try to connect it.
Okay, ma'am.
Next, Dr. Senthil Kumar, kindly prepare yourself. Ma'am, can you permit Dr. Senthil Kumar, sir?
Yes, sir. Yes, sir.
Ma'am, am I audible, ma'am?
Yes, sir. You're audible, sir. Kindly share your screen.
Yeah, yes, ma'am. Just a minute. Ma'am, is my screen visible, ma'am?
Yes, sir. It is visible. Please proceed, sir.
Good morning, ma'am. I'm here to present the topic morphological study on human scalp hair in relevance to diabetes mellitus. I'm just skipping the introduction part as we know that scalp hair is very important and it's also a psychological aspect in our daily life. And also we know that diabetes mellitus impact our multiple body systems that includes even skin as well as the hair. The aim of the study is to investigate the morphological characters of human scalp hair in individuals with diabetes mellitus. The objectives includes to analyze the structural variation in scalp hair between diabetic and non-diabetic, as well to evaluate the specific morphological parameters that includes hair shaft thickness, density, texture, as well follicular structure. The study population includes two groups of populations. One is diabetic individuals, around 70 participants, and group 2 is non-diabetic individuals of 70. The inclusion criteria includes the group 1 diagnosed with type 2 diabetes for at least 5 years, and group 2 is age and sex-matched healthy controls without any other metabolic disorders, including diabetes. The exclusion criteria, conditions affecting the hair growth, such as alopecia or any thyroid disorders, or if they are under any treatment like cancer chemotherapy. So the morphological analysis is done using the light microscope, examining the hair shaft diameter, cuticle structure, and integrity. Hair thickness measurement is done using digital calipers, and biopsy sample is also collected from diabetic as well as non-diabetic patients from the vertex region of around 10 samples from each group. So the results shows a table 1 with diabetic and non-diabetic, where we have done the two blood sugar estimation levels. One is HbA1c and the other one is random blood sugar. Diabetic patients and non-diabetic patients, we can see that there is a vast difference in HbA1c as well as the random blood sugar level, and it was found to be statistically significant, which suggests that these parameters are impacted in the disease group. The next table shows the age in correlation with the hair length and the hair loss. The hair length was measured and the hair loss was also estimated using a scale of 1 to 5. And the mean hair length was 10.2 and the hair loss was found to be 2.8. So this shows that metabolic disorders frequently lead to hair thinning and loss. So the observed hair loss scores could reflect the underlying impact of diabetes on hair quality and health. And this is a hair morphology table which shows a hair color. The hair coloration was checked out using the Fishers and Salas hair color chart, which is a standardized method to assess the hair coloring. Hair form, we have just checked out the straight, sleek, wavy, and frizzly hairs. Hair texture, quantity of the hair balls, that is the curliness of the hair, as well as the baldness, that is widow's peak. So when you see the hair colorness, the most common hair color is around 60 to 60.6%, which is common black in color, whereas the other colors what we have found is a gray color, and a few patients has reported with the reddish brown color also. We have excluded here the hair dyeing. Apart from the hair dyeing, these are the natural colors what we have found from the patients. Hair form, the straight hair is the most common, whereas followed by the sleek hair, which is the least common area. And hair texture, we have the medium hair texture where majority of the patients has reported, and the fine and coarse hair textures were less common. The quantity of the hair, normal hair quantity is the most prevalent when compared to the diabetic patients, but no participants reported having thick or dense hairs. Hair walls, clockwise direction is predominant, and most participants do not show any baldness, that is a widow's peak, which is around 69.7%. Coming out of the hair diameter, the diabetic patient's mean diameter was 75, whereas non-diabetic patients, it was 85, which shows that the non-diabetic patients' diameter was higher when compared to the diabetic patients. Coming out of the cuticle integrity, the diabetic group showed 35% cuticle damage, whereas the control group showed only the 10% cuticle damage. This is also another findings which is reported in the study, that cuticle damage is more common in diabetic patients. Hair thickness, the diabetic group showed a mean thickness of 60, whereas the non-diabetic patient showed the mean thickness of 72. And the thinner hair in diabetes could be a sign of nutritional or circulatory deficiencies that comprises the hair follicle health. Coming out of the hair density, the diabetic group showed 120 hairs per centimeter square, whereas the control group shows 150 hairs per centimeter square. This low hair density observed in diabetic participants, possibly due to impaired follicle regeneration. So when we correlate with the HbA1c level, blood sugar level of the patients, there is a negative correlation between HbA1c and hair shaft diameter and found to be significant, and negative correlation between HbA1c and hair density also and found to be significant. The poor glycemic control is associated with more pronounced hair morphological changes. Coming on to the analysis of the hair pull test, and here we have done the hair pull test and trichogram, where we have the normal, which is of 14:1 ratio, whereas in case of diabetic patient, we have encountered with 8:1 percentage. So this shows that the ratio of anagen and to telogen, that is 80 ratio, was calculated and found to be less in diabetic patients. And this is a histological picture of a scalp biopsy. It's a normal picture. Here you can see the non-diabetic group and the diabetic group. The non-diabetic group showed the normal scalp biopsy, whereas the diabetic group has findings of a reduced number of layer of squamous epithelium in the hair follicle, as well as the dermis showed reduction in the number of hair follicles in diabetic group. And the sebaceous gland and erecta pili, these are the important glands which is needed for giving sebum to the oily secretion to the hair. And this is not accompanied by the hair follicle, and we have found out in the section separately. So the interpretation of the result, the observed reduction in hair shaft diameter and cuticle integration in diabetic patients suggests that they have negatively impact hair follicle function, and the clinical relevance of this could serve as a non-invasive indicator for monitoring diabetic related complications. And this can be used as a diagnostic potential for non-invasive marker for assessing diabetic complication, as well as for the therapeutic approaches to mitigate oxidative damage to hair follicle and the glycemic control strategies. The quality of life, addressing hair-related issues can improve psychological as well as psychological well-being in diabetic patients. To conclude, diabetic individuals exhibit thinner and more fragile hair with damaged cuticle structures compared to non-diabetic, and hair morphology changes could be a potential marker for systemic metabolic changes in diabetes. Finally, the scalp hair analysis could provide insights into the broader metabolic health of the individuals, offering it as a non-invasive tool for early detection of diabetes-related complications. So the limitations, we have taken only a small sample size, and this is largest studies needed to confine with all the findings, and no longitudinal data for the progression of hair changes was done. And the future research, what we are planning for is investigate the relationship between glycemic control and hair morphology, and also explore the potential therapeutic intervention to mitigate the hair damage in diabetic patients. So these are my references. Thank you.
Thank you, sir. That was an interesting topic, slightly different from all other topics. So can I ask you a question?
Yes, ma'am, please, ma'am.
Yes. So what are the underlying biochemical and metabolic factors in diabetes mellitus that might influence the structure of growth of scalp hair?
Ma'am, actually, we have the SOX gene, which is affected in the diabetic mellitus. And this SOX gene has influence on the hair morphology also. So when the SOX genes are affected, automatically the hair morphology also gets changed. As well, we have the hyperglycemic control of the patients. When they are not under glycemic control, when the glucose level is more, it also influences the hair follicle damage, ma'am.
So can you relate this as a reliable biomarker in detection of diabetes mellitus?
Yes, ma'am. We are continuing this with the future study. We are going for the genetic level also. So to find out which is in diabetic patient, what is that actual gene and how the gene sequences is affecting, so that we can detect the condition earlier itself. If they are prone for diabetes, then we can detect their hair damage also earlier, and we can give the appropriate treatment.
Okay, sir. Thank you so much, sir. Thank you.
Thank you. Thank you.
And the next participant, is anybody is ready? Mr. Sakti?
Yes, ma'am. I ready.
Yes, your slide is visible. Please.
Ma'am, my topic is antibacterial activity on terminus indica food cells. Next slide. Introduction. Terminal indica is a long-lived evergreen advert found in various countries and regions and medical purposes, and terminal industries and produce large amount of green fruits, and when green fruits fully and tree becomes fast-like structure, brown and reddish brown color, the fruit will become a sweet or sour. Next. Over time, every part is used in Ayurvedic and medical system and nutritional benefits, and furthermore, and termica for antimicrobial activity, commonly used and treat food. According World Health Organization report, and termica content be majority objective. First, collection of the termica indica food to extraction of the termica indica the analysis of the antibacterial activity against pathogens. Next. This methodology, antibacterial efficacy, agar will be diffusion method, ethanol extraction and thermic and fruit cells are evaluated against pathogenic bacterial strains and specifically on Bacillus and E. coli. Next. Next. Is collection and extraction. First on collection of the thermic and fruit cells, and the next one powder form. Next extraction. Fruit cells and thermic and was collected in Trivikanagar village and Tirupattur district in Tamil Nadu. 5 grams of powder shells and combined 100 millimeters liters and sterile ethanol heated in 60 degrees Celsius or 30 minutes and followed by cooling. Next. This is antibacterial activity result and agar gel diffusion method. This is our result. Next. My conclusion, the study of focused on production ethanol extraction, Termica indica fruit cell, emerging technique research, experiment herbal science, and develop cost-effective environmental friendly method and cell extracted Termica and fruit cells. I conclude my research work on good antibacterial activity against pathogenic organism. Thank you, ma'am.
Exactly. That was very short and nice work too. This is your PG project?
Yes, ma'am. I will start.
Okay, so you have selected 2 pathogens, right? E. coli and Bacillus subtilis.
Bacillus.
Yeah, E. coli and Bacillus. Why E. coli and Bacillus? Why you didn't select for other organisms also? Like in what basis you selected E. coli and subtilis alone, Bacillus alone?
Ma'am, already 4 microorganisms selected, ma'am. That Bacillus and E. coli organism more than Jonas formation, ma'am. I choose that 2 organism, ma'am.
Okay, good. Then about the tamarind extract. So what potential extracts are present in this tamarind plant, which is giving that antibacterial activity? Did you find out that the phytochemicals present in tamarind plant?
Ma'am, nanoparticles, my.
So you're synthesizing nanoparticles from tamarind or directly the tamarind extract you're using for antimicrobials?
Ma'am,
Your topic is the fruit shells.
Extraction with ethanol, ma'am.
Okay.
Next, starting with antibacterial activity.
Okay, fine, Shakti. Thank you.
Thank you, ma'am.
Can I call the next participant who is available?
Ma'am,
Yes,
shall I proceed, ma'am? Ma'am?
Is that Soundarya?
Yes, ma'am.
Yes, you're ready?
Yes, ma'am.
Yes, please share your screen.
Ma'am, is it visible, ma'am?
Yeah, it is visible. It is visible.
Okay.
Please start.
Happy noon to everyone. I am Soundarya, Department of Biochemistry, studying at DKM College for Women, Vellore. Today I am going to present about bioactive screening studies in fenugreek seed, and I am so excited to share my knowledge with you and explore about the fenugreek seeds. Now, let's take a look at the bioactive screening compounds in fenugreek seed. First, what is fenugreek seed? It is easily available plant. What is the bioactive screening of fenugreek seed? It is a process of identifying and characterizing the bioactive compound present in the fenugreek seed. The bioactive compounds such as hydroxyleucine, saponins, flavonoids, galactomannus, steroids, alkaloids, camphorol, and niacin. Let us see about this in briefly. The edible seeds of the fenugreek plant, the botanical name is Trigonella phenum graecium, or referred as the methi seeds or fenugreek seed. Fenugreek, which is indigenous to the mediated room and the Indian subcontinent, has been used for the millennia as the dietary supplement. It includes protein 20 to 30%, fiber 40 to 50%, carbohydrate 20 to 30%, and it contains the vitamin A, B, C, and E, mineral, potassium, magnesium, calcium, and iron. It is used for the digestive problem like diarrhea, constipation, and also used for the respiratory condition like allergies, asthma, and bronchitis. It is also used for the menstrual health, relieving bloating, cramping, and other PMS. PMS, which referred as a premenstrual syndrome. It is also used for the skin and hair care, encouraging healthy skin and hair growth. Current studies. It belongs to the family Fabaceae family. It is also known as the bean family or Leguminaceae. It is a member of subfamily. Appearance. It is an annual herb that can grow to be the 1 to 2 feet tall. It has long, slender stems with proliferate leaves that are grey green.
I'm sorry to interrupt. Can you go to the core content of the work? Skip the introduction.
Okay, ma'am. The bioactive screening in fenugreek seed, the first compound is 4-hydroxyleucine. The structure, it is a non-protein amino acid structurally similar to the branched chain amino acid leucine. The function of the hydroxyleucine is to have the potential anti-diabetic and anti-inflammatory effect. The mechanism of action is to regulate the blood sugar level by increasing the insulin sensitivity and glucose uptake in the skeletal muscle. The pharmacological effect is to be reported to have the hypoglycemic, hypercholesteremic, and anti-inflammatory effect. The second compound is saponins. Saponins are a group of glycoside composed of a sugar moiety linked to the lipophilic core. The function of the saponins has to be reported to the antioxidant, anti-inflammatory, and cholesterol-lowering properties. The mechanism of saponins is to reduce the inflammation by inhibiting the production of pro-inflammatory cytokines. The pharmacological effect have been reported to anti-inflammatory, antioxidant, and anti-cancer effect. The third compound is flavonoids. Structure of the flavonoids is a class of polyphenolic compound characterized by the three-ring structure. The function has to be shown to the antioxidant, anti-inflammatory, and anti-cancer properties. Mechanism. It may help to protect against the oxidative stress by scavenging free radicals. Pharmacological effect have been reported to have the anti-inflammatory, antioxidant, and anti-cancer effect. The fourth compound is galactomannose. It is a type of polysaccharide composed of the mannose backbone with galactoside. The function of the galactomannose have to reported to have the potential prebiotic and immunomodulatory effect. The mechanism is to help to stimulate the growth of beneficial gut bacteria. The pharmacological effect have been reported to have the prebiotic, anti-inflammatory, and immunomodulatory effect. The sixth compound is camphorol. Camphorol is a flavonoid characterized by the three-ring structure. It has reported to have the potential anti-inflammatory, antioxidant, and anti-cancer cell. The mechanism of action how to reduce the inflammation by inhibiting the production of pro-inflammatory cytokines. The last compound is niacin. It is a flavonoid glycoside characterized by the three-ring structure. It has been reported to have the potential anti-inflammatory, antioxidant, and anti-cancer effect. The mechanism of action is to reduce the inflammation by inhibiting the production of pro-inflammatory cytokines. Conclusion. Research on fenugreek seed has revealed that they contain the bioactive substance with the wide range of characteristics such as anti-cancer, anti-inflammatory, and antioxidant. Anti-cancer bioactive substance found in fenugreek seed help the anti-cancer properties and prevent tubulin polymerization. Anti-inflammatory substance, it is found in the fenugreek seed, have the potential to reduce the inflammation. Antioxidant, it is an active substance found in fenugreek seed, have potential antioxidant properties. Low blood sugar glycemic control may be enhanced and blood glucose level lowered with the fenugreek seed. If preventing the diabetes type 1 and type 2 may benefit from the fenugreek seed, positive effect on the blood lipid profile, antibacterial, pherenone, and carbonyl are among the volatile chemicals found in the fenugreek seed that may have the antibacterial qualities. Another excellent source of dietary fiber is fenugreek seed. Nevertheless, high fenugreek dosages could result in the detrimental decline. Thank you, ma'am.
Thank you, Soundarya. Can you have started the work or you're just reviewing the topic?
Recently only I have started to work, ma'am.
Okay, so the fenugreek, it is a well-known herb, we all know. And the primary bioactive compounds you're selecting or the secondary one, like what is used for this anti-inflammatory and anti-diabetic effects?
Ma'am, it is the primary bioactive compounds, ma'am. There
Okay.
are
So,
many primary bioactive compounds present, ma'am, but due to less time, I just explained only few, ma'am.
okay, fine. So, what different extraction methods you are using for it? Whether solvent extraction or cold pressing method, or just the powder you are giving it? How you have selected your
I
way
just
of?
done with the powder method, ma'am.
Okay. So, how did you're extracting from your powder? You're running the oxalate for it, or making a decoction out of it?
Ma'am, I use the chocolate extraction method, ma'am.
Okay, okay. Thank you, Soundarya. Thank you.
Thank you, ma'am.
May I know, is anybody is ready now? Ms. Rama Devi, Dr. Vinu, Dr. Vinayaka. Anybody is ready?
Ma'am, shall I present, ma'am?
This is Sulochana.
Yes, ma'am, Slokshna.
Please try.
Yeah, ma'am. Ma'am, can you see my screen, ma'am?
Yes, I can see.
Yeah, ma'am. Okay.
Yes.
Yes, ma'am.
Yes, please present. Please.
Yeah, ma'am. And my topic is peptide modeling and a structure characterization of hydrolysate protein from trigonalaphenum, and it's as an anti-cancer agent. Plus, trigonalaphenum grazium is a fenugreek seed, has been traditionally used for medical purpose, including anti-cancer activity. This studies aim to characterize the molecular structure of the fenugreek seed hydrolysate, investigate the polygenetic relationship, and predict the anti-cancer potential using in silico modeling. And polygenetic analysis relieved fenugreek evaluation relationship within the Fabaceae family in silico modeling, including molecular docking and QSAR studies, predicting the binding affinity and anti-cancer activity of fenugreek derivative compound. And this studies provides valuable insights into the molecular mechanism underlying the fenugreek's anti-cancer effect, paving the way of further investigation and potential therapeutic applications. Okay. Hydrolysates are the compounds produced through hydrolysis of chemical reaction involving water in contact of fenugreek. Hydrolysis refers to the breakdown product of its bioactive compound. Hydrolysates may be used in lead compounds or adjunct in cancer therapy. And hydrolysis may be used in skincare product also, because it has the property of antioxidant and anti-aging effect. And there are several types of hydrolysis. And first one is protein hydrolysis, polysaccharide hydrolysis happens, and polyphenol hydrolysis. These are types of hydrolysis have several medical values, and it's may be contained in several crops and seeds. Production methods, they are enzymatic method, chemical hydrolysis, and microbial hydrolysis. An enzymatic method, we have to break down that fenugreek compound, and a chemical method means we have been using some bases of fenugreek compounds, and a microorganism to break down microbial product. And colon cancer specific studies, the first main process of my project is about anti-cancer agent. The fenugreek seeds, it's used for the best to rectify the cancer, especially for colon cancer. And potential benefits is it's enhance the chemotherapy and reduce side effects and improves patients' outcomes and prevention of colon cancer. There are so many applications of this hydrolysates which presents in the fenugreek seed, like it may be used for cancer therapy and dietary supplement, and also for antioxidant and anti-aging effect, like cosmetics, using for cosmetics.
My research direction is characterization of idolysate composition and structure, investigation of idolase bioactive and mechanism of action, optimization of idolysis condition for improved health and efficiency. And these are the phytochemical properties which are present in hydroalysatates. And these are the pharmacological properties. And mechanism of action, reduction of cancer cell growth and proliferation, apoptosis activation of and cell cycle halt, and prevention of agenogenesis and metastasis. And methods, I have been gone for bioinformatics tools. First, just
Can you move faster?
Can
you move faster, please?
Yeah, sure, ma'am.
Results and discussion.
Just results and discussion.
Oh, okay, ma'am. Okay, ma'am. Okay, ma'am. And these are the result and discussion. And I retrieved the sequencing from NCBA. These are the sequence. And I go for Amigo. And these are the results which have been obtained from Amigo. And gene expression analysis, I use the tool of JCAT. The cross species alignment tool. An Aqua tool, automated call and usage tool has been developed to perform the high throughput sequence analysis, aiding statistically profiling of codon usage. And I got from 0.84, which is highly expressed, which means we can easily high positivity for developing drug or designing a drug. It may be give a profitable results in it, because the 0.84 is a highly expressed value, CA value. And I done for scan pro site service. These are the results I have been gotten, and I got a height and proparam for primary structure analysis of this hydrolysis, and got for secondary analysis, and Swiss model for tertiary analysis. Why I'm doing this sequence and structure and function? Because when we have retrieved the sequence, we can step into that structure. When we know about the structure, we can easily predetermine about that function. If you know about the function of this compound, we can easily develop a drug according to their benefits. So I'm done with bioinformatic tools. I done with dry labs, and I'm stepping to this wet lab. And the conclusion is fenugreek compound is mostly used for anti-cancer ability. So I'm just research about the supplementary treatments. So I'm working on this designing of the drug, and my future perspective is on clinical trials and mechanistic research of this fenugreek seed. After I went to this characterization of hydrolysis composition and structure, investigation of hydrolysis bioactive and mechanism of action, optimization of hydrolysis condition for improve the yield and efficiency sequence for this enzyme hydrolysis. And I did this fenugreek compound for a grind format Saxlake method in wet lab. And I done the ethanolic extraction procedure. And I have been get the powder form, and I have been set that this the sequence that powder form into the validation. Once I get the result from the validation, I will going to do the sequence for that protein hydrolysis, and we are going to upload it in NCBI database, because we didn't get a fine database like sequencing in about the hydrolysis compound. So I'm just giving the hydrolysatate enzyme sequencing, and I'm going to upload it in NCBI database.
Okay, thank you, Sulochana.
Thank you, ma'am.
I have a question for you. Can you name the protein hydrolysate which has been identified as a potential anticancerous agent derived from this fenugreek?
Ma'am, hydrolytic is an enzyme, ma'am. It's a peptide bonded, and it's
Yes.
about 41 amino acid, 41 to 51 amino acid. The length of that's hydrolytic, and I just retrieve it that, and I got that powder form also. But I just want to wait for the validation process, ma'am. Once I get the validation process, it's completely done. Then only I can upload it, and I can know about the active sites of that protein.
Okay, so you can justify that the structural features can contribute the bioactivity, the
Yes, ma'am.
proteins, the
Yes,
peptide
ma'am.
sequences derived from.
Yeah, ma'am. Because I got it that highly expressed form from my bio tool. I already got it that highly expressed for it's about 0.8, right? So I'm hoping I'm getting a positive result from that. So I'm just given that my samples to its validation. I'm send it out that.
Okay.
Once I get the validation result, I will completely get my samples can be enabled for designing or developing the drug, ma'am.
Okay, thank you, Sulochana. Thank you so much. And we have a few more participants. Ms. Soundarya, you have finished.
Ma'am,
Dr. Vinod.
shall I do the presentation, ma'am? I am Dr. Bhaskaran M from Coimbatore.
So I'll just check whether your name is in the list, sir.
Yes,
Dr.
ma'am.
Bhaskaran.
21. Ma'am, I don't think this
Okay,
his name
you
was.
didn't give the name from PSG College of Nursing.
Yes, ma'am. PSG College of Nursing, Coimbatore.
Dr. Bhaskaran, sir.
Yes, ma'am.
Yes, sir. Please proceed.
Ma'am, my PowerPoint is visible.
Yes, sir.
Thanks for giving this opportunity to present this virtual conference. Today, I am going to present about the research topic on the effectiveness of coping strategies regarding fear of missing out on academic performance among students at selected colleges, Coimbatore. My voice is audible, ma'am? Ma'am?
Yes, sir, audible.
Introduction.
Yes, sir, you're audible.
Introduction. Academic performance is a critical aspect of any student's educational journey, as it helps shape their future career perspectives and opportunities. When studying healthcare disciplines such as nursing and pharmacy, it becomes essential to assess the factors influencing academic achievement in these fields. This support system can hold students accountable and provide them with resources to overcome academic challenges. Overall, these coping strategies can help healthcare students develop a healthy balance between academic and social activities and avoid the anxiety and stress associated with fear of missing out. Additionally, setting realistic goals and breaking down long-term projects into smaller tasks can help students to stay on track and avoid feeling overwhelmed. Another coping strategy is developing a support system such as study groups or seeking help from professors or academic advisors. Academic performance is consistent writing essential. It is a synthesis, emotional control, language, relational reflective is a relationship between with writing facilitators such as teachers, academic resources, and the self-reflections and the creative identity is exploring gaps in student achievement of transformative writing, which includes creativity, voice, and disciplinary identity, where confidence can help identify the most engaged writers. The statement of the problem, a study to assess the effectiveness of coping strategies regarding fear of missing out and academic performance among students at selected colleges, Coimbatore. Objectives are fear of missing out and academic performance among students in the experimental and control group. Second one, to assess the effectiveness of coping strategies regarding fear of missing out and academic performance among students. Yes.
No, sorry, sir. Other participants, kindly mute the audio. Please, it is disturbing the speaker's voice. Sir, you
Third
please continue.
objective, to correlate between the fear of missing out and academic performance among students in experimental and control group. Fourth one, to associate the fear of missing out and academic performance with selected demographic variables among students in experimental and control group. Research methodology for this study. The research design is through experimental pre-test, post-test control group design. Setting for the study is PhD College of Nursing and PhD College of Pharmacy, Coimbatore. The variable of the study, independent variable, coping strategies, dependent variable, fear of missing out and academic performance. Sample and sampling technique, population is BS Nursing and B-Form second year students. Technique is probability simple random sampling technique. Sample size is 120 students based on the power analysis formula. Tools and instruments, we have used 3 section A, B, and C. Section A, demographic variables. Section B, fear of missing out scale. Section C is academic writing, self-efficacy scale. Criteria for selection of the samples, inclusion criteria, study who are willing to participate. Exclusion, students who are not present at the time of data collections. Data analysis per and unper t-test and high-square test. That result and analysis, the table 1, effectiveness of coping strategies, academic performance in fear of missing out in interventional and control group. These are the dimensions, totally 6 dimensions: personal, social, and novelty seeking, and interpersonal and social media usage dimensions. The overall result, it representing that the mean test of the students in pre-test 161.85 plus or minus 22.02 in pre-test, in post-test 153.13 plus or minus 36.95, in unpaired t-test 3.82. That is the experimental group. T-value is, unpaired T-value is 3.82. That level of significance is P less than 0.05 level. In control group, in pre-test, mean and standard deviation is 153.22 plus or minus 34.16. In post-test control group, mean value is 147.13 plus or minus 36.95. The unpaired t-test value is 2.46. Here is not significant. In effectiveness of coping strategies on academic performance of among students, here these are the 3 dimensions: writing essential, relational, reflective, and creativity identity. The total scores, it representing that mean value of pre-test is 51.35 plus or minus 18.74. In post-test, mean value is 52.82, standard deviation 22.73, unpaired t-test value is 4.439, which is significant at the level of P is equal to 0.37 level. In a control group, that pre-test mean is 50.13 plus or minus 17.75 standard deviation. In post-test, mean score is 50.8 plus or minus 16.33. There is no significant found in control group. The correlations between the academic and fear of missing out performance among the students. Here in that R value indicating that pre-test value, it's significant at the level of 0.401. In post-test level, in correlation value is 0.691. It representing that the post-test level is much significant comparing with the pre-test level of correlations. Then in associations between the fear of missing out and academic performance among the students using the ANOVA technique, that the 2 significant is found in the general. In gender, there is F is equal to 3.75. That significant level is 0.05 level. In post nursing and pharmacy students, it's much more significant at the level of 0.001. F is equal to 44.42. It shows much, it is having that much significant comparing with the other demographic variables. These are the implications we can implement in that in the field of nursing education practice, nursing administration, and nursing research. In nursing research, nurse educators should incorporate the importance of impact of coping strategies to reducing fear of missing out in the nursing curriculum. Apart from the nursing curriculum, in that other field also they can implement. these things in coping strategies. In nursing practice, nurse should give importance to give counseling to reducing fear of missing out and enhancing the academic performance among school and college students. In administration side, it should work collaboratively regarding impact to reducing fear of missing out and enhancing the academic performance. Other healthcare personnel in primary health center staffs and schools and college and teachers who implement the school and college health services also. In research field, in nursing research, the finding of the present study serves as a basis for other research scholars to conduct the further studies on coping strategies to reducing fear of missing out and enhancing the academic performance among students. The study concluded that the aim assessing of the effectiveness of coping strategies regarding fear of missing out and academic performance among students. Hence, the investigator concluded that there was significant improvement in the level of academic performance and reduced the fear of missing out among students after administration of coping strategies. Thank you.
Thank you, sir. That was an interesting topic. Sir, I have a doubt. Like you have spoke about FOMO, that is the fear of missing out students, and
Yes,
you applied it for the nursing students. So
yes.
this specific demographic factors like age, gender, or academic discipline, like not only nursing, can it be applied for? Will it be effective for the other strategy students also?
Yes, ma'am. In demographic variables, we have listed, it's like the monthly income, where they are staying, whether they are in hostel or day scholar, like that. There and there is no associations. These are the two things it's associated. So we have included in that
Okay,
presentation.
so is it common for all age and gender, sir? Be it a
Yes,
boy
ma'am.
or a
We
girl or
use
any
it.
age?
Much of the studies, the research findings also, we have much of evidence with discussed in the discussion chapters, in 5th chapters also. The many studies they are conducting. It's like fear of missing out. They will feel that they are not, if they are entering that first year, they are going to second year, they have that fear about how they are going to study. They want to miss that in social media also. So in healthcare work, field and all, they have to give much importance in that field of education. That time also they will feel somewhat they are missing that mobile, and then they are not using that social platform. It's like then other field also they have the similar feelings. If we are implementing this type of coping strategies with that other field also, they will get the benefits.
Okay, thank you, sir.
Thank you.
Can I call the next participant? Who may I know who is ready to present? The missed out participants. Dr. Vinayaka, Dr.
I think
Jnanendra,
everything is completed, ma'am.
sir. Avladana, sir.
I think everything completed, ma'am. But you have energy, you have stamina.
Sir, there are absentees, so I was.
Okay, fine, ma'am. Fine.
Okay.
We supposed to complete everything, ma'am. Ma'am, can you give some concluding remark, ma'am?
Yes, sir. So I really appreciate all the participants who have presented in various topics, and the budding participants also I could see, and progressing research participants like assistant professors also presented here. So based on the categories, the results will be informed later. So I congratulate each of the participants. Apart from winning a prize or not winning prize, all are equally important and equally appreciated here for their efforts in preparing the slides and presenting it in a conference. I thank everyone, and I appreciate everyone. Thank you for this opportunity, sir. Thank you, sir.
Thank you, madam. Thank you, madam. Thanks a lot for your availability.
Thank you.
In a short run, I am very fortunate to have you as a jury in this day. We came to the concluding session. It is, I'm not planned to this much time it consumes. I wholeheartedly thank our college, our rector, our principal, our vice principal, the members of Institution Innovation Council. I wholeheartedly thank the resource persons, two personalities in this occasion, Dr. Nalini from Muscat and Dr. Pavitra from Chennai. Thanks a lot, ma'am, for your availability and your presentation and coordination is highly appreciated. I thank all the students, faculty, participants. As ma'am told, as jury ma'am told, we have to take some time to scrutinize the marks and we have to give the best presenter, but student category, faculty category, as well as research scholar category. That ma'am will take care. At the end of the instructions, before 20th of this month, kindly send your full paper to the respective email address. We are collect the abstract or full paper. We are going to release the conference proceeding with ISBN before 30/12/2024. I request our jury ma'am to help us and we will include her as one of the editorial board members for that conference proceeding with ISBN. With this short note, I would like to thank each and everyone for your availability. Thank you, and all. God bless.
Thank you, sir. Thank you.
Thank you, ma'am. Thank you, ma'am. Now we are winding up the session. Thanks a lot. God bless.
இந்த படி பார்ப்போம் அந்த பேராகிராஃப. போயிடுச்சு இந்த பேராகிராஃப். சேட்டை நான் படி பார்ப்போம்.